Good evening, y'all. Welcome back to another Sunday night. Thank you for your patience as I try and sort out the audio issues. Hi, Chris. Hi, Nate. Welcome back to another stretchy Sunday night here, coming to you live from Chicago. I think there's something a little bit odd going on with my audio. I don't know how it sounds to you out there over the internet, but I think something a little bit strange is going on. Yeah, right, Kenneth? Something is like clipping or peaking, and I can't figure out what it is. The real shame is that it might be that my mic itself is damaged, in which case there's not much I can do. Because level-wise, ask Clippy, yeah, it's pretty brutal. Level-wise, I'm not peaking. Like I have a couple different audio monitors in my field of view, and it's not. At least it's not clipping in software, but it might be clipping on the hardware side of things, or something may actually be damaged. I mean, it's not a particularly fancy microphone. Honest assessment on a scale from to awful. How is it out there? Because I know certainly when I'm watching stuff on the internet, like it could be like a 320p stream, and like the visuals could be awful, but if the audio is not good, then I'm just not interested. So I'd rather know, because I think I have a backup plan. It would take just a moment to set up, but it's fine when you're not enthusiastic. So it really is clipping. That's so interesting. It does make me wonder if it's on. Well, here's what I'll do. If you'll bear with me, we'll make tonight. Oh, I didn't even start the we're getting started soon thing. Maybe I won't do the we'll get it started in just a second timer that we usually do, because we might just take a second. Let me turn off all my onboard audio filtering and see if that helps at all. Does this sound any different to anyone out there? I guess I also. We get started whenever. So, ironically, today I usually do an audio test with my wife about, I don't know, take an audio-video stream test locally with my wife about half an hour before we start. Today is the only day I did like a test like 2 o'clock this afternoon to see if you could hear the fan that I've got going for solder fume's sake in here. Palmer says no different, which is exciting. Well, that is both good and bad, I suppose. But so I was playing around with like different amounts of fan noise, but I wasn't really listening to myself. Like I was like, record a video clip, play it back. Can you hear the fan if it's here? Can you hear the fan if it's there? Yes, no. But I didn't really think to like listen to like how the audio was. And also I would talk in my like troubleshooting voice, not the like we're learning things tonight voice. So that's kind of a bummer, huh? Give me just 1 second here, y'all. So I have this, I believe the term is bad, shotgun mic here that I have used before, which might be a little bit better. It might also be a lot bit worse. But if it's not clipping and it's just a different like audio quality, like maybe that's more plausible. So I'm gonna mute me for a second. Actually, I'll do this. Be right back in 1 sec. If I turn the mic on. So here's a different microphone entirely. This was the one, yeah, no audio now for sure. Is this still clipping, I wonder? Level might not be right, because it's literally now a shotgun microphone sitting on the desk in front of me. Still clipping. Why would that be? I mean, it could be the audio. I mean, the audio interface is a really generous term for what I'm using. To get the sound into the computer. OBS problem? Possible. I've restarted OBS, I think. That's not a crazy idea, Chris. Well, if you'll bear with me, I'm actually not 100% sure what happens to the stream if I crash OBS and then start it up again. Does your audio interface have a pad? Palmer doesn't even have knobs. It's not. I'll show it to you when I can figure out how to show it on the camera. It's not very good. Well, how do I do this? Here, I'll tell you what. If this stream doesn't come back, the chat will, I think, still be open even after the stream. I'm not going to end the stream. I'm just going to stop streaming from my computer. I'm going to reboot OBS. I'm going to start it up again, and hopefully you'll see me back here in like 26 seconds. I guess I could reboot the whole computer. That won't take very long. Solid State Drive. You know, I don't think anyone's coming here for like things going terribly great. Thanks, Kenneth. Kenneth, we missed you last week. There was a certain, well, there was no lack of sass, but there was certainly a problem with. All right, I'm going. You're all great. All right. Hopefully we are back in business. How is the audio? Thanks, Palmer. How is the things? How is the clips? Stopped on a good frame. Did someone get a screenshot of how frozen it is? Here, well, this will be an exciting. You get a little largely the same. That makes me crazy. And I think a lot of people have now left, which is fine. We'll have a fun time tonight regardless. The only thing I can think to switch microphones is it's the actual audio interface that I'm using on the computer, which is a bit of a bummer. So I guess we'll just plow ahead. Is it here? I'll tell you what. Is it? I guess it doesn't matter. Just trying to think if there was some way that I could like talk a little bit more quietly. Maybe I'll turn the music down. You can turn your volume up, and I'll just talk a little bit more quietly, and hopefully the peaking is not as bad tonight. And we'll do kind of an ASMR session. How is this? Is this audible? Is this intelligible? You can also get the joy of watching me adjust color temperature live, because Logitech cameras don't save their color temperature settings, which is always very exciting. It was better, louder, and clipping. All right, fair enough. I'll be louder then. I will turn the background music back up, and I will leave my gain structure the same. That's a bummer. That's a super bummer. Well, I mean, now, like, that's the lesson learned, is that, like, I should invest in an audio interface that costs more than $20, I think is the lesson there. Because after a dozen of these, clearly we're going to use it. So, all right, well, lesson learned. This is kind of a throwback. I don't know, Chris, you might have been here that very first week 0, like, before this was a thing, where I had, like, the audio from my microphone and from one of the webcams going out to the stream. And that was unfortunate. It's definitely not that, because I have metering now on everything, and I can tell that I'm not going over 2 microphones and causing phasing. But I don't know what it is. Super bummer. I mean, I can turn off compression. We'll give it. I want to take just like 2 more minutes because buggy audio makes me crazy, and then we'll get started with tonight's topic, which is soldering. I don't think we've actually said it yet. There you can see I took away the Arduino-ness of the banner tonight, because technically soldering is not, strictly speaking, Arduino related. We're just going to talk about soldering for electronics projects, for assembly, for electrical projects, and things like that. And for those who have just popped back in, I know that the audio is a little bit buggy tonight, and I apologize. I think my audio interface is on its way out. What if I use webcam audio? Let's give it a try. Palmer, I will take, and Palmer is a professional sound human. I will take anything. Now, I have 2 identical webcams, so the question is it going to be, which webcam is it going to be? This webcam or other? Also got to up the camera switching software. It's also complicated. So this is option number 1 that we're talking on right now. Palmer says no. All right, how about this webcam? So this is now, so I can also increase the gain of either this. So that's this webcam. That's the webcam over there. I must want webcam. I select, you can't see on my screen, with a little more gain. I've got this. So here's an option. This is option number 2, let's say, which is the webcam directly in front of me, which may be a little bit echoey. If this is clipping, then I have clips hiding somewhere in my room, I think, which I hate. So that's an option. Palmer's professional sound opinion on option number 2. Option number 2 is not clipping so far. Is the volume decent? A little echo, sounds good, no clip. I think echo, feel free to chime in, but for I think echo, like as it's just getting noise now, is better than clipping. So if this is more decent, and I can gladly take that up like 4 dB. A little more gain, yeah, sure. So here's plus 5 dB from where we were a moment ago, I guess. And this is like normal Jeff in the evening talking voice. So if this feels decent, then roll with this for tonight. It's funny. I've always thought of that shotgun mic. Shotgun again, a really generous term. My crappy shotgun mic as as like the backup mic for these things. Clearly, I should have tested it beforehand. I never thought about like this has a microphone on it and the other webcam has a microphone on it and like all the things. So, so this is going to be a great solution. Thanks, Lee. Hi. Hi, how are you? I hope maybe Travis is here as well too. Part of the discombobulation of this evening, I mean, let alone the fact that it has been a discombobulating week in the world, is that I have a slightly different setup on the workbench this week. And I think if I zoom the top camera out, be able to see it a little bit better. Well, you probably can't. Focus on the bench for a reason. Everything kind of shrunk in so I can do this really close up, so we can look at things close up while we talk about soldering, but that's making everything feel like really squeezed in and compressed in a really kind of strange way. It's just like it's shaking things up, which is exciting. Also just trying to get my my Stream Deck software that does the camera switching from a local device to connect. For some reason, complaining about doing, which is something that's happened a couple times before. Always exciting. Is she connected? Oh, it's because I'm so far from Wi-Fi, I can't even find it. It's all just going gang. Wi-Fi, yes, I love Wi-Fi. I've had more Wi-Fi issues in the past 2 weeks since I upgraded my Wi-Fi through Comcast than I have in any. It's all good. We're here tonight. We're gonna have a great time. Let's jump into it and talk about soldering. And you can bear with me. If you've bared with me for the past 11 weeks, I think you can bear with me for these first 16 minutes of tonight as I figure out how technology. But let's talk a little about our topic, which is soldering, which is going to be great. So things we're going to talk about today. So in things that has also been typical in the past few, the sort of like outline that I roughed in the middle of the week turned out to be a little overambitious. I didn't think we would get through it even in a Jeff Glass 90 minutes. 90 minutes. So it's pared down just a little. But things we're going to talk about: fundamentals of hand soldering, types of solder and sizes of solder, and what you should buy. Soldering tools and tips. Soldering tips and soldering tips. Starting strong. Thru-hole and surface mount soldering, or SMD soldering. They're all the same principles, but two slightly different things you might do. And we'll look at a couple of different soldering. Solder braid and a solder sucker. We are not going to get into hot air or oven work tonight. That's the piece that I'm taking off the table because I think that's the whole itself. And I think hand soldering is a more fundamental skill that we talk about. This is definitely an evening that I do a manual change for here. Show my face. This is definitely an evening that I'm excited about. Audio is randomly dropping out for a word at a time. Bummer. You know what I think it is? I think it's because when I point my face away from this camera toward this camera, it probably, like if I go over here, it's probably dropping out because I have a gate on it. So we'll gate off. And that might be a little bit weird. But hopefully that is now a little better. So now even if I come over here and talk at the computer, talkie, hopefully that is working now. A little bit better at least. Now there's probably still some audio ducking there, but hopefully that's just a little bit better. Let's see here. Seems a little fixed. Yeah, I definitely had the gate still turned on from when it was the lav mic. Let's see. How are we going to best? I mean, mostly we'll be looking at the soldering table this time. I'm still just trying to get now that I've rebooted OBS. This is like rebooting a sound console at showtime. It's like, if you don't have to, you don't want to. And so now, like, the Stream Deck is not syncing, and it's going to be just a fine night. But really, we're going to bust through some slides, and then we're going to get to the table and show you some techniques, and that'll be really the gist of tonight, and I think that is going to work just fine. Palmer says, can you help me understand why and when to use flux pens, and what does flux do? I would gladly. why don't we just dive in? All these problems will feel so small once we're actually into the meat of tonight, huh? So let's get into some stuff. Let's talk about soldering and what it is and why you do it. So soldering is defined as the process of joining two metallic parts together by melting and putting a filler metal, a solder, into the joint between those two metallic objects, which has a lower melting point than both of the objects individually. So we're not taking two metal objects, putting them together, and melting them together. That would be a form of welding. Welding, among other definitions, is when the two contacting metals, the two surfaces, actually melt into each other. If they don't physically melt and change phase, what you're doing is either soldering or brazing. And I didn't know this before this week. The definition of what is soldering, like melting metal into a gap, and brazing, which is also melting metal into the gap, has to do at the temperature at which that filler metal melts. If it's below, I think 450 C, it's soldering. If it's above, it's brazing. Brazing tends to be a technique, therefore, that you use for like connecting pieces of metal together. Like you might braze brass pieces together, because welding brass or even welding aluminum is very complicated. The aluminum welding process is, I think, a little bit, depends how you do it, but it's very tricky because of like the visual properties of aluminum. But you could braze them together or find some other mechanical fastener way to hold them together. So mostly what we think about is hand soldering. And hand soldering is when we use a tool like a soldering iron or a soldering pencil or a soldering gun, and I have one in front of me here, to heat up a hot bit of metal, a metal solder, to flow into the gap between, say, one electronic part and another, or an electronic part and a circuit board, or an electronic part or a wire and a piece of perf board, like we looked at last week, which is a piece of often fiberglass or plastic that has little pads of copper, little circles of copper that are meant to be soldered to, is causing that metal, this silvery metallic metal here, to flow into the gap between those two pieces and create a mechanical and electrical contact between them. That is the gist of soldering. And so what I think we're going to do is we're gonna go at this just a little bit backward. Like we could talk about all the different kinds of tools, the different kinds of solder, the different kinds of fluxes, and then finally, like 2 hours into this thing, solder something. But I think, for those of you who are already like, well, maybe my bedtime's in 20 minutes, like this audio is kind of crap, I don't know, what am I doing here on a Sunday night? I think we're gonna do like fundamentals of hand soldering technique, and then we'll like break down, go into like types of soldering when we would use them and do a demo on that, and types of flux, which I think we only have, well, I have a couple types as I look around the workbench here that we can play with. So let's do soldering technique first, and then we will come back to like the geeky details, as it were. Let's find something to solder. I mean, this'll work. But we'll need a piece. How about a resistor? And I should say, clearly the audio is a whole new experience tonight. The camera work is also a little bit new. It's quite a bit closer and quite a bit zoomed in. So if you're ever like, hey, that thing you just did, I couldn't actually see, or the light was weird, or like, can you show us a different angle? Like, just let me know, because this is an experimental camera night for sure. Chris says it's all in. Bring on the flux jokes, bring on the melting joke, like whatever you got. Tonight's the night for soldering jokes. I'll take it. So actually, I'm gonna get this piece of perf board out here because it already has some sturf on it, and I'm gonna take this piece of perf board that I pulled out as a part of a demo a couple weeks ago, and get it into our vise here. So as we talked about last week in the making it permanent part of the evening, perf board is literally, as I said just a moment ago, a piece of plastic with aluminum or copper plated holes, sometimes on one side, sometimes on both sides. This is a single-sided piece of perf board. So really, I'm only going to be able to solder things on the side that has this, I think it's an aluminum layer on this one, and not on, obviously, this blank layer. A mistake that I often make, though you are smarter and probably wouldn't, is I put the shiny side up, because that's the good side, and then I start putting components, like this resistor, into the shiny side, and then I turn it over and realize, oh, actually, I would want to be soldering this through from the back, but there's no pads over here. So now you need to take the thing off, you turn it over, you put the things in on the non-plated side, you flip it over, and you solder from the back. Not that you can't necessarily solder some components from the top, as it were, but most of the time with a single-sided perf board, you want to be putting your components on the non-plated side and soldering them on the plated side, if that makes sense. So just to make this, well, I guess this is actually not a bad side. I was gonna say I have the option to snap this in half if I want to, and we'll see. Maybe if I get filled with rage about how Stream Deck is betraying me, I can snap this in half later as a little therapy. But for the time being, I think this will be fine. We'll talk more about work holding for soldering later, but for right now, like I say, I just want to get a manual soldering demo done. Ken says, get proto board with plated holes and pads with both sides because they're so cheap. They are so cheap. I have a bunch of this stuff from days that I was doing a lot of projects and I had very, very little money. So this took me like 2.5 months to ship from overseas and was dirt cheap. I have like dozens of these. So partly why I'm using it tonight is to help use it up out of my stock. But like we talked about last week, you can get perf board in all kinds of different sizes and arrangements and things. So I've got that arranged. Let's say I'm just going to not worry too much about circuit layout for tonight. I want to solder this thing in place. I have here a resistor that I'm going to solder into some spots on my perf board. This resistor came with straight leads in the pack, and I've just bent the leads over at about a 90-degree angle so that I can solder them in place to my perf board here. I'm going to go ahead and get my iron turned on. So I have my iron in its little stand here just to show you. And we'll talk about irons and guns and pencils and things later, but just to do a fundamentals of soldering demo, I'm going to get this heating up and give that a moment to heat. Most of the, or really all of the soldering kits you get come with a little sponge down here, and we'll talk about solder tip cleaning as well. My sponge has disintegrated over the past few weeks, and I don't feel like spending the money on another one. And we don't use kitchen sponges in our house. We have cleaning cloths. So I have a piece of wet paper towel here for those who are curious what shenanigans are going on down there. Chris, I think this is, what size resistor is this? I think the light is playing tricks on me, so I'm just going to measure it because I can. This is a 50 ohms. 50 ohms exactly. Oh, I know what reel this is. I was like, why is this reel sitting out? I have a bunch of 50 ohm resistors as part of a ham radio project. They're not RF resistors, but they were used for biasing a circuit that needed a bunch of 50 ohm resistors that I was playing with a couple of years ago. So I have this roll of like resistors I don't really need anymore. So my soldering iron is hot, and we'll talk about temperatures in a little bit too. So, fundamentals of soldering. I have my part, my iron is heated up. I have a little bit of cruft, you can see on that tip from previous soldering adventures. So I'm going to pounce it in my brass wool down here, inside of my stand, just to get the excess solder off of it. I'm going to use my wetted surface, my wet surface, to just sort of wipe a little bit of the excess solder, because that's sort of the steam and the wet help to pull the excess solder off. So now I have a nice shiny surface. I'm going to take my roll of solder, and I promise we're going to talk about types of solder as well. I'm just going to pull that off a little bit here so I have a little bit of the end of the wire in my hand. I'm going to slide this back over so we can see what's going on. Take my resistor, fold the leads over at a 90-degree angle so I can insert them into my board. And let's say that I've previously determined that the perfect spot for this is right here. Perfect. And then I'm going to bend the leads outward underneath my perf board here. And we did this last week too. That's just a really easy way for leaded components to sort of hold the component in place as you're working with it and getting it soldered in. Can I zoom in anymore? Yeah, I sure can. So, work at a little bit of a weird angle, but I think it's going to help you see on the camera what's actually going on. So I'm going to take my soldering iron, which my iron at the moment, and like I say, we'll talk about tips in a little bit. Tips and tips. Mine has this chisel-shaped tip, which I really like for through-hole work, and a lot of people do. It's sort of flat along one dimension and chiseled along the other. So I'm going to take the chisel part, take the flat part of that chisel, and press it into the junction of the lead and the pad here for a couple of seconds, get both of them nice and hot, and then, I'm going to watch what I'm doing. I'm going to poke a little solder in there, then take the iron away. Let's see how we did. We did all right. There's actually, here, I'll show you on the camera, that's actually a little bit too much solder. what you want really is a perfect sort of concave angle on your solder. You need a little inward bend like the tip of a volcano. You don't want a ball, you don't want an outward curve, you want an inward curve there. So the fact that that's a little bit domed, I mean, I'm not going to necessarily go back and worry about that joint if I'm doing this as a hobbyist, but I just know like that's a little more solder than I need for this application. So let's do one more of those. And again, so you can't see out here because I zoomed way in, but I am wiping off my tip in between each of those joints over here. If you're doing a lot of joints in a row, it can be really good to sort of dab off your tip in the brass wool in your holder between each joint. Although, you know, sometimes I'm just going joint, 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 joint. The brass wool doesn't absorb as much heat as, of course, wiping it on a wet paper towel or a sponge does. So if you're trying to keep your tip hot and keep moving, that can be really nice. I find that I usually have to pounce on the tip, pounce it in the brass wool, and then give it a little wipe on the sponge just to get the last little remnants of solder off there. So let's do one more of these. Oh, Travis, we did miss out with the beer of choices tonight. I think it's a repeat. I think I have done, oh, let's see. Let me get my face back up on here. Get up here, face. Face. I'm drinking a Bodum from Half Acre Brewery, I think. I know it's a Bodum. It says it right there. I think I have done this one before. I really like Bodum. It's really juicy. It's really good. Some friends and I went to like the launch party for it at Half Acre Brewery. So it has a special place in its heart for me, and we have a bunch of it now. So Bodum for me tonight. I'm curious. I definitely missed what y'all are drinking tonight, whether that's water or something else. Dan says he does not use the sponge at all. Totally good. I usually find that a little bit of sponge work helps clear off the that tip a little bit. Palmer is also anti-sponge. Totally fine. Whatever works for you. I also know I've had people say that the sponge can cause your tips to delaminate a little bit faster, that they, you know, the coating on top of it can tend to separate from the inner core, which is, I think, often copper for heat conductive reasons, and that the sponge, the heat shock of putting it on a wet sponge can cause that to deteriorate more quickly. I've never personally seen that happen, but I also don't necessarily hold on to my tips all that long because I either break them or lose them or whatever. But that is something to know. And yeah, if the wool is good enough, then totally good. Let me come back here. So let me do one more solder joint here, because I think many, if not all, of the people watching will have done a solder joint before or have done some hand soldering before. So I'll do this one, and then we can move on to some deets. But just so we're all on the same page about what our soldering process is, I'm gonna come in here with my soldering iron. I'm like, it's funny, I've got an image of myself at a monitor view, which is actually bigger than what real life is, but I'm really not used to soldering on camera or like using a microscope or anything. So I'm just looking at it here in person, but you certainly could use a soldering magnifier of some kind. All right, so that looks pretty good. Let's do a little inspection here. That one's all right. Again, maybe a little bit too much solder, or more than necessary. Like I'm not gonna rework that as a person doing a hobbyist level work, but like that's just like a little bit more of a ball than it needs to be on that closer one there. That first one is actually looking a little bit better, but that's fine. You know, that'll work for us. And then, like I said previously, we're going to take our flush cutters and just trim those leads off right above the solder blob. And make sure you keep track of your little conductive jangly Jews here, these little legs that we've snipped off, because they can fall into places in your circuit you don't want them and short things out. So that would be no good at all. Let us see here. So that is the gist of hand soldering. Sorry, y'all, I'm just super getting used to the new workflow of having to like click on scenes manually in OBS to change them like it's, you know, March. That just will not fadge. Palmer said, did I miss the difference between square and round pads? Oh, good question. Let me take you back to the table. You know, if I'm going to be doing this all night, give me 1 second. I'm going to do a little... Oh, that was disorienting. There we go. The square and round pads are just a choice that this manufacturer made to help you delineate sort of which pads are where. I think on this, there's a spacing of 10 holes in between pairs of square pads on each bit of perf board, but that's just specific to this manufacturer. So if you're like, oh, you know, I know my component's going to take up like a space of 8 holes or 0.8 inches, because the holes on a perf board are 0.1 inches apart, then it'd be easier to like, oh, I have some visual references for where those holes might line up. But again, that is manufacturer specific. Like this perf board we were looking at earlier doesn't have anything like that. That's just a choice that this particular manufacturer in China chose. They don't really mean anything. Good question though. Yeah, that's the gist of hand soldering. You shoot a component through, put your iron on it for a couple of seconds, heat up both components, apply the solder gently, let it flow around your two components, remove your solder wire, and then pull your iron away. Some ways that soldering can go wrong. I'm going to take another sacrificial resistor here and show you. What you want is for both of your components to be basically above the melting point of solder. When you touch the solder to them, what did I say? Chris, whatever I said, I didn't say. Let's say. If you apply your iron so that it is only touching the lead of the component or the pad, then obviously that component is going to get a lot hotter than its companion, and the solder will tend to stick to the hottest thing in its vicinity. Iron touching both the pad and the wire. So you want your iron touching both the pad and the component. You don't typically want, the goal is not necessarily to touch the hot iron with the solder itself. You want the joint itself to be hot enough to melt that solder. Now, especially for larger parts, what I often find myself doing is applying the iron and then feeding in the solder right at the point where the iron and the part and the pad meet, just so they all get a nice dose of that heat. That turned out pretty good. You can see that nice concave shape there. Here, let me lift that up a little more. You can see how that's sort of bowing inward, and that's what you want, because that tells you that the hot solder was attracted to both the pad and the part, and its surface tension caused it to, sort of suck into the joint between those two, and that tells you got a really nice, strong connection. Let me see here if I can screw this up. I'm going to try, well, here, I probably can. So far, there seems to be a good indication this evening that I am able to screw things up. So I'm going to clean my iron off here. I'm going to hold my iron just, let's see, how do we show you this? Maybe I will just turn this board a little bit so we can see what's going on. I'm going to try applying my iron only to the lead of the resistor, and really I'm like a full quarter inch above the pad down here. And now if I apply my solder, well, that's not a solder joint at all. That solder has only stuck to the lead of the component. In fact, even if I put my solder down here at the base, I'm getting a little bit of melting, but not a ton. And I'm relying on the heat transmitting through the legs of that component down into the base, which is not what you want. You want to use your iron to heat everything up, and then get the solder in there. You can have a similar problem where you are heating up only the pad and not the component. Let's get another sacrificial resistor in here. See if I can do a better job of screwing this one up. Let's see here. So there's my resistor. Clean the tip off there. I should say, and I don't think I said earlier. So I'm ready for a new solder joint. And I have a nice clean tip. This soldering iron's tip by itself is not necessarily going to make great thermal contact with the leads of the component nor with the pads. So what you want to do typically before you get your iron in there and get it touching those components is take your solder wire and just touch it just a little bit, just to the tip there. You want just a very tiny bit, and that liquid interface is going to help there be a lot more thermal conduction between the tip of the soldering iron and your components. So now when I press that iron on, give it a couple seconds. Oh, I was going to screw this up. Well, this will be a good one, he says, promising. I think he's not sure he can deliver. Yeah, that's pretty good. Again, a nice concave shape there, a nice volcano shape to that pad that we just did. If I just press my soldering iron to the pad, sort of far away from the component, give it a moment here, you might get something where the solder is preferentially sticking to just the pad. Actually, that turned out pretty well as well. Part of the nice thing about doing small components for handheld circuitry is they're so small, they have so little thermal mass that they're going to be heated up by the nearby objects that get hot. So they're fairly forgiving in terms of soldering. As opposed to something much larger that's going to take a lot more heat. And if you're not getting everything uniformly hot, and I think we'll do some soldering of some large things later, you can have solder that sort of sticks to only one of your two parts that you're trying to solder together. Palmer says, which components will generally be more heat sensitive than others? I've heard that LEDs should get a quick breath to cool before moving to the other side. Yeah, so LEDs can be very heat sensitive. Some integrated circuits, some chips are pretty sensitive to heat. LEDs, especially when they are in their on state, are really sensitive to excess heat. So if you're ever fixing like LED tape, you should always turn it off first. And especially those little surface mount, like the 2835 or 5050 LED chips, are pretty sensitive to heat. There also can be electrostatically sensitive. So my iron, and we'll talk about iron in just a second here, is not necessarily statically grounded, so it could have a static charge on it, and that can also potentially damage ICs and LEDs. Other things that are heat sensitive. Any components that have germanium in them, which is a little bit unique, like a germanium diode, if you were a ham radio nerd, for example, tend to be fairly heat sensitive. What you can do in a situation like that is, here, I'm going to need another sacrificial resistor. But if you have a part that you're worried about heat, and it's a leaded part specifically, what you can do is, so let's say this is a germanium diode that I'm really worried about, or a transistor or something that I'm worried about damaging with heat. If I put it through the holes on my circuit board, and then I take a bit of an alligator clip, one of these clippy wires, and clip it to the lead on the side that I'm soldering, that is going to act like a little bit of a heat sink and prevent, well, not prevent, but encourage heat not to flow along that lead all the way to the component. So that when I solder it, now certainly this lead is still going to get hot, and that alligator clip is now going to act as a heat sink and soak up some of the heat that I'm dumping into this joint to make this solder happen. But that can be a really easy way to help mitigate heat if you're worried about specific components. Honestly, like the surface mount, like the 5050 LEDs are the most common ones that I've seen, especially people soldering them when they're turned on. Most of the time, you don't have to worry too much about soldering heat with like hobbyist level components if you're working quickly. Palmer wants to talk about temperature. Palmer, that's a great question. Why don't we talk about hardware and soldering irons, and then we can talk about temperatures to run them at. I think that'll be fun. Let's see. Still not Stream Deck, so that's all right. But we'll do things a little bit manually today, and that'll be fine. So things we want to talk about. And again, now that I'm turning this way, you let me know if you can't hear me. But I think I'll be okay as long as I speak up a little bit here. Use that years of acting training voice. So to solder, to do hand soldering, you need a hot thing of some kind to provide the heat at your joint to get the solder to flow into the crease or the junction between your two metal parts. That might be a soldering iron or soldering station. You could have a soldering pencil, a soldering gun, or solder tweezers are kind of an interesting thing. I've never used them, but they are out there. A soldering station consists, it typically is just a handheld iron. This iron down here that is our handheld implement. We have a base station which provides a regulated amount of current or power to that iron to cause the tip to heat up. And often this will come with a stand and a little brass sponge and a little regular wet sponge, and that will be sort of the parts of your kit. Pretty much every soldering station, although I guess not every single one, will have circuitry in it that responds to a temperature sensor, a thermistor, in the tip of your soldering iron proper. So when you set the temperature on your soldering iron, it's not just saying, well, I know 500 degrees Fahrenheit is X amount of power. It's actually responding to the temperature at the tip and moderating how much power it dumps into the tip itself to cause it to heat up to a certain degree. There are many different brands of soldering station. I put a few links on the eBash page, and I think in the description of this stream as well. I personally am using the one that's pictured here, the Heiko FX888D. Is a pretty different station. This is the 888. The 888D has a digital display instead of a dial. I wish mine had a physical dial instead of a digital display, because the display is kind of cumbersome. This one ran about $100. It's a really decent soldering station. You can find them on Amazon, at Micro Center, at Fry's, at your local retailer, wherever you want to get them. They're pretty good. In the past few years, sort of off-brand soldering stations have gotten pretty decent. I linked a couple of those down below too, but Aoyue, Aoyue makes some really decent ones for like 30 or 40 bucks. Now, are they necessarily going to last you the next 30 years? No, but compared to a soldering pencil, which would be something more like this, which is a device typically that plugs directly into a mains outlet, and has no temperature sensing. It's literally just like a big resistor hooked up to mains, more or less, covered by some metal that gets hot, which might run you 15 bucks. Investing 30 or 35 bucks in a soldering station, that, you know, a 60 watt or a 70 watt soldering station, is such a good investment, because you will, and I guarantee it, and I have been there, you will throw out more soldering pencils, you will spend more on bad soldering pencils than you will on your first decent soldering station, and it'll last you a lot longer. I thought for years that I was really bad at soldering, and true story, I was like, I guess I just don't know how soldering does. And then I was at Kenneth's apartment one time, I think your college apartment, Kenneth, and you were like, hey, try this. And I was like, oh, I'm okay at soldering. I wasn't great then, but I'm okay. I've just been using crappy 25 watt Radio Shack soldering irons for a long time. So if you're interested in soldering and you're using a pencil, like a plug straight into a wall soldering pencil, and it's not doing it for you, try a soldering station. They really are pretty cheap. Heiko and Weller are kind of the two, like, if you want to invest, like one that'll last you a couple decades, they're pretty good. Metcal is the really pricey one. Don't go out and buy a Metcal. They're like hundreds, if not thousands of dollars. But the features you get on a really primo soldering iron are the ability to really precisely regulate temperature and the ability to deliver a lot of heat to the tip when you need it. So when you place your soldering iron on a joint to start heating it up to melt some solder into it, you're obviously sucking heat away from the tip. And so the soldering station is going to pump some more power into the tip to try and bring it back up to that target temperature. Better irons tend to be better at like maintaining that really high temperature as you're putting them to work. Kenneth thinks Metcals are overrated. Totally fair. Lots of fans of Heikos out there. Yeah, Travis loves a Heiko and Chris loves a Heiko. Palmer says he just still has his 30 watt pencil to be resentful of. Yeah, this really is like an area where, because like one of the things that I always think about is like there is no right or wrong answer for like what is a good tool, what is a bad tool, but it's always worth having the conversation of what's good bang for your buck. A soldering pencil is bad bang for bad buck. A $35 soldering station is so worth it. And if the tips are crappy and your tip dies in 9 months, you buy another tip for $3 or $4, and you're still way ahead of the game. Yeah, soldering pencils, not so good. Very bad. So, things you should look for in a soldering station, wattage. So, it's literally just a measure of how much power the soldering station is going to use, is going to be able to dump into its tip to put into melting your solder. 60 to 100 watts is a decent range. 45 watts is probably fine, but like a lot of the standard like basic ones are 60, 75 watts. That's perfect. That's enough for doing almost every small to mid-sized joint until you get into soldering. I have soldered 12 gauge wires with my 75 watt iron. There really are plenty. If you're doing something a lot bigger, like if you're soldering like number 6 wire, there's actually possibly a better tool for the job, the soldering gun, that we'll get to in a second here. You want your soldering station to give you the option of having interchangeable tips, and most of them do. If you're getting an off-brand one, do a quick internet search and make sure you can find the interchangeable tips for it. You don't want to be stuck with a random brand soldering station that doesn't it comes with 5 tips, but you can't get replacements. A lot of them are either compatible with Weller or Heiko, but they won't necessarily tell you that. So do a quick Google search and see, the Aoyue 97 takes Heiko tips. Fine, totally good. Not all of them do, but worth Googling. You want that stand with that brass wool and that sponge. It's just really convenient. You can also buy those stands separately. Like I said, Heiko, Weller, Metcal is the money. Aoyue off-brands, all totally good. So, yes, soldering pencil is thumbs down. We've addressed this already. Soldering gun. So this is not really a tool we would necessarily use on our small electronics workbench. But the soldering gun essentially is the larger version of a soldering pencil. It is a heating element often hooked directly to mains through a transformer, often with a switchable heat setting. So you pull the trigger and it starts heating up very rapidly. The power draw on them is usually somewhere between like 140 and maybe 250 watts. So you can really dump a lot of heat into something. If you were soldering together really large wires or small pipe, if you were doing like soldering together brass sculptures or something like that, like taking brass rods and making solder joints between them, something with a lot of oomph behind it, like this might be great. For our workbench, it's really, really overkill. And they typically don't have that temperature control function. They literally are just like pull trigger, 150 watts dumped into the tip. But just so you know, they're out there in case you run across them. You're like, why is this? They're also really cheap. So if you're ever like, oh, I really need to solder this giant beefy, number 6 power wire onto my circuit board, which better be a really beefy circuit board, maybe a soldering gun is the tool for you there. Just a thought. Yeah, that's the gist of soldering tools. Let's see. Palmer says there's a controversy about people who found that welder stations don't have fuses. I mean, a fuse is, I suppose, a good thing. I guess I fail to see exactly why you would necessarily, like, is it to, like, the idea is that the fuse is protecting the iron, like if you had mechanical damage to the iron or the iron cable, that it would just continue like spewing out power. I guess that's a good thing. I have never really had a problem with iron shorting out, but I guess it certainly could happen. Certainly if it's kicking around the workbench for years and years, like that would be an interesting problem to have. Palmer says, oh, the TS100 and TS80 style. Yes, I do want to talk about those. I don't have a link to them in the slides, but come with me to the magical world of Amazon. I'm pretty sure I did link to them in the description for those who are interested in clicking through to this style of iron. Let's see, we can do a little bigger. Yeah, there we go. So, come over here, iron. So the TS100 and TS80 are these little miniature soldering pencil style devices that have popped up in the past couple of years that have onboard temperature control, are powered from DC, so you could power them with a battery bank, especially a USB-C power bank that can give you like 100 watts nominally out of itself. If it's the right kind of USB-C, it'll negotiate it for you. I have never tried one of these. I'm really curious. A lot of people, like a popular thing to do is to buy one of these little TS100 modules and power it either from a battery bank or from an old 19.5 volt laptop power supply. Let's see if there's a little, yeah, so it's this little soldering pencil that you provide your own power supply for, or you buy one in a kit that has a power supply with it. I'm super curious. I know Big Clive likes them. I have never played with one, but I'd be super curious. I think they are very much like targeted, like, yeah, here, power your soldering iron off your laptop, or throw it in your work bag with a battery bank. That's what I would be curious about, is like power it off of your portable, phone charger battery bank. I have my doubts that its thermal mass is going to be really good, although they're fairly well reviewed. Like, I'm sure they really do get up to temp, but do they have enough thermal inertia in that tip to really do good soldering work? I'm curious. Palmer, I would love to hear what you think when you get one, because that would be really curious. Butane soldering irons. Yes, I have used and I like. There are some really crappy ones out there. I have not linked to any because I'm not remembering off the top of my head what the decent brand was. Kenneth, if you can help me, you might be able to help me with this poll. I know Jeremy K has one that he likes, and that's the brand that I bought for the museum. And then we left the museum for 2.5 months and it's gone. Yes, what you want is a butane soldering iron that's easy to use, that recharges directly off of like the butane canisters. If this TS80, TS100 thing works, I would use that over butane for sure. Because the butane's kind of cumbersome, and it's also, there's an active flame inside of it when you're igniting it. So they're like a little bit dicey to use in sensitive situations. I bought one for the museum because I'm always having to like solder, you know, hundreds of feet from my workshop, and it works pretty well. But it is always weird, like you have to, you know, basically ignite the flame inside of it, let the catalyst glow, and then you put a metal cover down over the catalyst, and it continues having a reaction inside of this like catalytic block that maintains the heat of the tip, and they work pretty decently. But like I say, if I had a portable like battery powered iron that did just as well, I would throw the butane in the trash. If I can think of that brand in the next 90 minutes, I will. Actually, it might really be 90 minutes now, given how these things go. I will shout it out. So I guess the gist of it, the gist of the soldering iron portion of the evening is get yourself a halfway decent soldering station, and you can do that for 30 or 40 bucks. You can also get soldering stations that have extra features in them, like. Is there an easy way for me to? Probably not. I'll just show you Amazon. That'll be fine. You all know what Amazon is. AOUA. So there's all these kinds of different soldering stations. A lot of them have extra like wingdangs and doodles. You can get ones that have hot air rework stations built into them. We used to have one of these at Chicago Shakes. You can get ones with power supplies built into them, with desoldering pumps built into them. But if you're just looking for like a really basic soldering station that'll do the job, here we go. AOEA 60-watt soldering station with removable tip, ESD safe, which means it's not going to carry a static charge, right? It's got a sponge in it. It's got a place for your iron. If you were like, is it really worth it? Buy this $30 one. Change your life. And then, of course, you can get all the ones with the fancy features if you want to. I don't think having a power supply in your soldering station is particularly handy, but you do you. Hot air work could be handy if that's what your pleasure is. Here's a supply of tips for 10 bucks. All this is very good. Here's one with a built-in digital temperature control, 75 watts, a Yeehaw one for 45 bucks. Also, I'm sure is fine. So really, like, get a good soldering station. You will not regret it. Yeah, that's the gist of soldering irons. We should talk a little bit about soldering tips, but I think I'll save that until we talk about surface mount devices. Because that's really where it's going to become relevant. Why don't we talk next about... Oh, Palmer was curious about flux. Let's talk about flux, and that'll lead us into a broader discussion of solders. So, what is flux? Here, we can zoom this out a little bit. Get out of here, thru-hole. What is flux? This is a flux pen. This is a pot of flux. Which looks like snot in a can. This specifically is rosin paste flux. I don't know if you can. That might be a little small. Rosin paste flux. This one is a no clean flux pen. So, what flux is? So, when you take your bit of metal, which ultimately is all that solder is some metals combined together, a metal alloy, and you heat it up and you bring it into contact with your two metals that you're trying to bond together. What happens? Well, the sad truth is that those two metals that you're trying to bond are probably not the pure metals that you would want them to be. They are covered usually in a very thin oxide layer. Whether that's an aluminum lead or a copper lead or a piece of copper on a wire, there's going to be a very thin layer of, say, an aluminum oxide or a copper oxide on the around the metal object, because the object is exposed to the atmospheric oxygen that's surrounding it. And most metals react with oxygen. Now, the most common oxide we know of is iron oxide, which is rust, which happens to be a very, not strong, brittle, flakes off kind of material. Aluminum oxide is a very, very strong material. Aluminum oxide is, I think, what rubies and sapphires are. They're aluminum oxide with different impurities. Someone can check me on that. I think emeralds too. It's a very, very hard material. It tends not to flake away the same way that iron oxide does. And the takeaway is, oxides, both don't like to stick to other things. Certainly aluminum oxide and copper oxide don't. They don't like to stick to other things, so our molten metal is not really going to want to stick. And they're very bad at conducting heat. So we're going to have a harder time, getting the heat into our object to get the solder to stick to them. In order for solder, the metal of a solder, to make a solid electrical contact between two dissimilar or similar metals, there's actually a small layer of what I think is called intermetallization. Basically, the metal of the solder becomes blended just a little bit with the metals of your surfaces right at the point of the solder joint. And that's what allows the electrons to sort of flow across them as if they are one continuous metal object. An oxide layer in between an object, the solder, and the next object will interrupt that process of intermetallization, where the solder won't be able to sort of mingle at the very surface of those two other objects. And what you'll get is a solder joint that's called a cold solder joint that's not particularly conductive and not particularly strong. It will tend to shear along those planes of oxides that are sitting sort of between your two metal objects and the solder ball itself, which is not what we want. This all brings us back to flux. Flux can come in many forms, either an acid, or many of them are based on rosin, which is a snotty material. I mean, it's this stuff. And what they are designed to do is, when they are heated, they vaporize or liquidize, or both, and they etch away that oxide layer. They clean away that oxide layer on the surface of your two metals and allow the solder to A, to stick to them, and B, to do that little intermetallization thing that causes them to be a good electrical connection. They also, clean off any other kind of, if you had a layer of really bad oxidation or cruft or debris on there, the flux will tend to clean it off because it is mildly corrosive. Now, we've been soldering away without having to put any additional materials onto our circuit board here. I've been throwing solder at it. And really what I've been doing is throwing this solder at it, which specifically is a rosin core solder. Let me see if we can see that. So I don't know that we can get anywhere near close enough. We need a microscope to see. And then, of course, I've got a solder ball on the end there. But if I snip this off, maybe we can see it. I can see it. I don't know if you're going to be able to. Yeah, my resolution's just not quite good enough. Down the very middle of this piece of solder, there is a string, essentially, of rosin that is impregnated into the solder wire itself, so that when it heats up, when you apply this to a joint, you get rosin, you get flux right at the point that you're doing your solder joint, and that is enough flux to have that cleaning effect on your metals when you're doing your solder. So for using a rosin core solder with relatively clean, not 20-year-old parts, you don't need to be applying any additional flux to your joints, right? Because when you apply your solder, you are fluxing the joint at the same time. And you can tell that you are, because you'll see these characteristic, and we'll see if they show up on camera, these characteristic little wisps of white smoke. Yeah, you see that there. So that white smoke is not the lead vaporizing, because you have to get lead really, really hot, the lead of your solder really hot in order to vaporize. That is the flux residue, some parts of the rosin or the acid vaporizing as you solder. That stuff, not good to breathe. We'll get to soldering safety a little bit later today. Ooh, but you know what I should do, and it's going to look super cool, is I'm going to put my safety glasses on. Now, I know this is going to be like a do what I say, not what I do occasion, but I will tell you a story from this week. I was putting together some parts for after last week's demo. I was like, I'm going to finish up this permanent Arduino thing, and I was working on a through-hole component, and I was soldering away, and my iron got a little bit stuck, and it flicked toward me, and I got a dab of solder right there, literally on my eyelid. Which was not super fun, and I count myself very lucky that it didn't go a centimeter higher, and it would have been a really big problem. So I'm not good about wearing safety glasses when I solder, but I encourage you to, because safety is good, and especially if you're doing through-hole parts, especially if you're working late at night, or you're working in really close, or I'm trying to work at this component around that other component. I'm going to put my head right down in there. It's really easy to have something bad happen. So I'm going to wear these a little bit smudgy safety glasses for the rest of my soldering demo. I should have been doing it from the beginning. Don't lose an eye to soldering an Arduino. That seems very silly. Let's see. Ken says, this is why you don't want to melt solder on the iron and then bring it to the part the flux is gone. Yeah, so when I sort of said earlier that you would want to sort of tin your tip, put just a little bit of solder on the tip of your iron just to help with thermal conduction, it really is a very, very, very tiny amount. Boop. right? So I have a little tiny dot there to help with thermal conduction. What you don't want, what Kenneth's making the point of, is you don't want to say, hey, I'm going to melt a bunch of solder on here, and then I'm going to take that molten solder and use that to go and solder my part, because the flux is already evaporating it away before you, or vaporizing or whatever it's doing away, before you get the solder over to your part. You want to have that flux be there and present and fresh as you're soldering. Now, if you're, and we'll get to solder types in a second here, Travis. We'll talk about lead solder and safety. And Chris, I see your question too about applying rosin flux from the tin. So if situations when for general soldering, for soldering the first time, you don't need external flux because you have typically a rosin core solder. Why would you need external flux? Why would you need this? So this is a liquid flux in a pen, has sort of like a paint tip type tip, and as you paint it on things, you press down, sort of prime it like a paint pen, you can rub it on. You can also get solder in this kind of snot format. I like to use a tool like a little plastic spudger to get the snotty rosin on if I've decided that's what I'm going to use. I have a box of, honestly, they're plastic sleeve Q-tips that I keep near the workbench for this, and all I do is I get a little snot on there, and then I would rub it onto my part in question. Now, for something small like these thru-hole parts, I probably am not going to use this snotty rosin flux because it's honestly overkill. Like that is a ton of flux, and if I put my hot iron on it, you'll see it's going to melt and smoke like a billio, and that's going to be overkill. But that would be sort of the kind of tool I would use: a chopstick, a toothpick, a Q-tip cut in half, something like that is a pretty decent tool. I use these because we had them in the house. We don't like them anymore, and they're cheap and disposable. So that is an easy thing for me to use. Kenneth uses flux in a little liquid bottle. Yeah, you can use like an old ink bottle or a dropper bottle, or a syringe I've seen people use. I like the solder pen. I also, if I'm going to be doing something that needs a lot of flux, like soldering something really big, I'll use the snotty stuff. But a lot of the time these days, if I need extra flux, I'm just going to use my solder pen. You'd want to use external flux when you are doing any kind of rework where you're not applying fresh solder, so you don't have that flux coming out of your solder wire. Let's say, so let's say that these sacrificial resistors here, here's a situation when you might need to rework something. Let's say that it's important to the aesthetics or the functionality of this tall component that it sits at a certain distance away from the board. Maybe it's a button that needs to interface with a panel, and I've made a poor decision about how I'm going to manage that, and I have to do it in the soldering level. You should do it at the mechanical level. But let's say I really need this to be stood off farther, or maybe this is a prototype, and I need to have this be sitting up harder. So I want to adjust this solder joint, but I'm still going to need it to be a good solder joint. I'm not going to just remove the part. I need it to be a good solder joint, make a good electrical and mechanical connection. What I might do is take some flux, either in gel or solid or liquid form. I'm going to use my flux pen, sort of paint it around my joint there. Just get it nice and wet. And now, when I come in with my soldering iron, I'm going to need some tweezers here too, so keep it very hot. I grip that component, I'm going to get my soldering iron into that joint, going to heat it up, and it's going to allow me to press that lead a little bit back through the board. We'll get real toasty now. There we go. Right, and now I'm still going to need to do an inspection because that was a pretty aggressive operation, but I can have some confidence that that's going to be a relatively decent solder joint. Now I can sort of see it's not. I've kind of made a mess of things there, but I might come back in with a little bit of fresh solder now and just touch that up. So clean the tip off, get in there with my chisel tip, heat that joint back up, flow a little fresh solder with rosin in it into that component, and let it cool. And that actually turned out not too shabby. And now I have my component sticking up out of my circuit board, which is critical for something, let's say, in this example. If you were doing rework of an old mechanical device, let's say you're fixing an old radio and you need to reflow some solder joints just to adjust some components, maybe you're taking some wire off them, putting some wire on them, using extra flux to maintain the wetting action of that solder is a good idea. Really, whenever you're creating a solder joint or recreating a solder joint in a situation where you're not using the solder wire directly, you want to be applying external flux because you want it to be acting like you're making a brand new solder joint with fresh wire. And to do that, to get that nice wetting action where the solder sticks to everything and has the properties that you want, you'll need to apply a little external flux. These are really cheap. You get a pack of these for like $12 and they work pretty well. I think this was like an $8 pack of rosin flux that I got years ago, and you can see I don't use this all that often, but it's nice to have around. All this stuff is really not terribly expensive. So that is the gist of flux. There are many kinds and species of flux. You'll see, mostly what you will see is either is rosin based. You will sometimes see them called type R, type RA, and type RMA. So type R flux is a rosin based solder. You might also have a type RA flux, which is a rosin-based flux with activators. That makes it a much more aggressive cleaning product. It really will eat into those surfaces just a little bit, not so much as to damage them, but enough that you would not necessarily want to leave the flux on your board after you've done your soldering. Complete everything, and then wash it off if it's safe to do so, or wipe it with a little isopropyl alcohol. Just to clean that RA flux off, just so it's not eating into your surfaces anymore. You also sometimes see RMA flux, which is activated rosin flux with moderators, I think is the M in RMA, is a slightly milder version. It's not going to eat into your board afterward, but it's still going to have that sort of deep cleaning effect. The most aggressive kinds of fluxes are acid-based fluxes, which you don't see a ton of, or at least I don't in the circuiting world. You see them sometimes in the plumbing world, where you'd be soldering, say, two brass or copper pipes together. You might see a really aggressive flux because it's got to make sure that copper is totally clean, so we get a really good seal with our with our solder, so there's no water leaking out of our pipe. The other thing that I've heard of that I've never seen or had occasion to look for is what's called an organic flux. And you might think like, oh, organic, it's like green and nice and happy skippy doo, I can pour it down the sink. Organic fluxes are organic in the sense of organic chemistry. They are a really aggressive flux, and you have to clean them off your parts within like the first couple hours after you use them, or they really will start to deteriorate your board. Or so I'm told. You might use them if you were like repairing old car parts or radios or things with really degraded like solder in them, because they're there to like aggressively clean your parts. I don't have any here to demo, and I'm not that sad about that because I don't have anything that's that crusty to use. Chris says, I'll add flux to my wick as I'm using it. Yes, we have not talked about solder wick yet and removing things, but that is a good recommendation. Since we've been talking a lot about solder and what's in solder, why don't we talk about solder some more? Move this out of the way. Come back to it in a little bit. Let's talk about solders. So solder, as I alluded to a little bit earlier, is just some metal. It's an alloy of two or more metals typically, that is formulated for a couple of properties. One is relatively low melting temperature, right? We don't have to heat this thing to thousands of degrees to get it to melt into our joint. That'd be really inconvenient. Ductility, right? So we can manipulate it. It's a flexible wire. We can sort of get it to be where we want it to be. And that intermetallization is important. Something that's going to bond to copper or aluminum and create that conductive surface across which electricity can flow through a solder joint, which is mostly what we, at least here, are doing with it, right? We're joining two metal parts together in a way that allows electricity to flow across them. So there are a couple of main species of solder, and Travis, this goes back to your question from earlier. Is this am I using lead-based solder? And the answer is, for these demos, I have been. The two major flavors of solder, and I think actually I have slides on this, are leaded and lead-free. So leaded solders come in a variety of flavors, but the two most common we'll see in the hobbyist world are 6040 and 6337. And those are simply solder wires that are 60% tin and 40% lead, or 63% tin and 37% lead. The tin is what's responsible for most of the electrical conductivity action. That's bonding with the copper or the aluminum of your circuit to create that positive conductive joint that electricity can flow across of. The lead is there to help with ductility, with low melting temperature, and it forms an alloy with the tin that means they sort of bond to each other. the difference between 6040 and 6337. So 6040 was thus the standard for electrical soldering for years and years and years. In fact, what I've been using tonight is 6040 because I have a whole bunch of it. Some of it I've acquired, some of it that was given to me, that I picked up for cheap, you know, whatever. I have a bunch of 6040. These days, if you're going to go out and buy something new, get yourself some 6337. What is the difference? Well, they're both perfectly serviceable, and in an environment like we're in, where we're working with typically relatively small parts, relatively small bits of solder that are going to heat up and cool fairly quickly, both will work just fine. 6337 is the mix of tin and lead that's what's called a eutectic mix. And that's the blend of two metals into an alloy such that both materials melt at the same temperature. If you have a non-eutectic mix, say, you know, in the case of lead and tin, the percentage that makes a eutectic mix is 63% tin, 37% lead. If you have more tin or more lead than that, what you get is a mixture that doesn't go straight from being a solid alloy to a liquid that flows. You go through this intermediate plastic phase where you have, say, some liquid tin with little bits of semi-solid or plastic lead in it. And we're talking at a very small grain level. We're not going to see big pebbles floating around. But you're going to get this kind of gummy plastic phase in a range of maybe 10 or 15 degrees around the melting point of a 6040 solder or any non-eutectic solder. With the eutectic solder, with 6337, you get basically solder that goes immediately from hard to liquid that flows and back to hard. And the reason that that's valuable is if you have a solder where some parts of it are going from a liquid to a solid before others, what you can get is a cold joint. Which is the state in which you've heated up your blob of solder, it's flowed in, and then as it's cooling, it moves a little bit. Now your wire jostles, or your part gets knocked, or just the vibration in the air, your part will move a little bit. And if the part that was previously next to it had already solidified, you can have a situation where the remaining liquid pulls the solder away, either from the pad or the part itself, leaving little voids, or at least areas of higher resistance, causing electricity not to flow well. So when you have you're trying to create a solid electrical connection, what you really want is a solder that's going to be a liquid and flow around nicely, and then as soon as it hits its 360 degrees Fahrenheit or whatever its melting point is, it will turn from a liquid to a solid all over the place all at once. Helps eliminate cold solder joints, which are joints that are not making a good electrical connection. Like I say, for small parts, 6040 works fine. If you have it, don't throw it out. Don't throw it in a landfill. God knows it's full of lead. But if you're buying some today, there's really not a reason not to just go buy a 6337. It's just a better solder to use. As far as leaded solder, we should talk a little about. So, thanks to the state of California and other regulations, you can no longer mass manufacture. Thanks, Palmer. Oh, I thought you were telling me to breathe. I see what's happening here. Oh, I just get so excited about soldering. The thing about solder is, so California and other states basically made it illegal to throw away masses of lead into a landfill. And in general, I think that is a good thing, because the environment is a good thing. But does that mean you shouldn't be using leaded solder in your personal projects? It does not. The amount of lead that you are contributing to the world by using leaded solder is negligible. And it's less than the amount of lead you're contributing to the world by doing everything else you do in your life that involves various bits of lead and lead alloys. Leaded solder is just better solder. It flows better. It flows freer. It's more liquid. It's less gummy. It's just a more pleasant experience. This is one of those things, like, if you're learning to solder and you think you're bad, and it might be because you're using lead-free solder. Let's do a little experiment here, because I actually have a little roll of lead-free solder here. So this is what are you? This is mostly tin. This is 99.2% tin, 0.3% gold, 0.5% copper. Is the the particular lead-free solder. Lead-free solders come in a whole bunch of varieties. A lot of manufacturers will tell you that they've solved lead-free solder and they've made it less of a pain. I've never found one that I like. If you do, God bless. Like, go out and use it, help the world. But there we go. Oof, I'm sorry for all the cameras. It's all just happening tonight. But let's do a little soldering with our lead-free solder here, and I'll see if I can show you the difference. So I'll take another sacrificial resistor here, pop it through the top side of our circuit board. Someday, knowing me, I'm going to forget to throw this board away, and someday I'm going to come back and be like, why did I need like 18 resistors just soldered in random places on this little tiny board? That, of course. So as I sort of started to tell the story, the reason that California has banned, California and a lot of now the United States and now Europe through ROHS have banned leaded solder in their manufacturing is because lead is a health concern. For home use, you are not in any way going to ever inhale this lead. It's not going to vaporize, it's not going to get on you, and it's not a hazard if you're working with it on your skin. It's only a hazard if it gets inside you. If you eat it, if you breathe it, that sort of thing. You're not in danger of breathing it. It is a good idea to wash your hands after working with leaded solder. It's just good principle. You're probably not going to ingest that much, but it's a good thing. Like, don't necessarily eat things with the same hands as you're working with leaded solder. Again, you're unlikely to have that much lead exposure through something like that, but it's good practice. You're in much more danger from the fumes of the rosin, which are kind of nasty. We're jumping a little bit all over the place to talk about safety, but that's just what this night is going to be. So don't eat it. Don't eat or drink while soldering, he says, while drinking his beer. What I would like, or I wouldn't say, don't like, I wouldn't recommend soldering with leaded solder, or really any solder, and then like eating, like, doing like the Denethor in Return of the King, just like popping cherry tomatoes into your mouth, letting the juice run down. Don't send your son to like die in a fruitless assault on Osgiliath either, but that's sort of beyond the point of tonight. More to the point, I'm not worried about solder, like any lead getting from this thing into my beer. I am worried about like my hands have some lead residue on them. I'm going to wash them before I go eat second dinner. Because I assume we're all kind of eating second dinner these days, because why not? Let's see. Kenneth points out, studies of people working with leaded solder not being able to do a higher lead levels. Yeah, sure. So you can get lead exposure if you're working with it a long time. Touching the rim of the beer, it's true. Like I'm certainly going to have elevated lead levels. And this is another like do as I say, not as I do thing. I am not particularly good about like, oh, I'm just gonna have a snack while I solder. Is it going to be long-term harmful? Possibly. Best practice would say wash your hands before you eat. Let's get back to our lead-free solder demo. I can show you a little bit of how different it is. So we're working on this resistor up here. Are we zoomed in as we can be? No, there we go. We'll see how visible this is. But I'm going to come in here with my tin gold copper solder mix. Really, if you're going to be working with a lot of lead-free solder, like let's say you're working in a prototyping lab or in a school environment or a hospital, like somewhere that really mandates like, hey, no leaded solder on campus, which you can't do. If you're going to be doing a lot of hand soldering or a lot of rework of lead-free solders, you can get special tips that are meant to work with lead-free solders that won't delaminate as quickly because there's a different mix of metals on them. So kind of tell already, it's a little hard to see, I'm sure. It's not flowing sort of as well. Kind of have to sort of get the wire of the solder itself to kind of move around between my pad and my component. I mean, I can solder these and get in there. There we go. There we go. I gotta nurse it in there. But it's kind of tending to like pile up on one side of the joint where I put the wire in, and then I have to sort of move the wire over to the other side to get it to flow over there. It's just not a terribly pleasant soldering experience. It can be done, like that's a perfectly cromulent solder joint, but really working with leaded solder is the way to go as a hobbyist. When you start your manufacturing run of tens of thousands of parts, leaded solder would be fine. Palmer asks, would lead-free solder dictate different tip temperatures? We haven't really talked about temperature in relation to solders. So each mix, let me come back to my face.
each mix of solder, each mix of metals is going to have a slightly different melting point. And if you're working with a non-eutectic solder, you remember that it's going to actually melt at a couple of different points. There's going to be a point where the tin starts to melt, it's going to be kind of plastic, and at a slightly higher temperature, the lead will start to melt, or maybe vice versa. You're going to have this what's called the solidus range, and no, I'm not making that term up, I swear. You have a solidus temperature range, you have a liquidus temperature range, and you have a plastic range right in the middle. For leaded solders, either 6040 or 6337, your typical temperature range of that liquidus phase will be right around like 360 to 370 will be the melting point. And that is the temperature that the actual wire needs to achieve in order to melt and flow around your joint. For a lead-free solder, they tend to be just a little bit higher, but not radically so. Like I want to say lead-free. I wonder if this one actually says on it. Oh no, it's a Radio Shack brand. It's going to tell me nothing, I imagine. It says, keep out of reach of children. Do not put it in your eyes. Do not breathe, do not feed to children. Yeah, I don't know. But tends to be just a little bit higher. That's Fahrenheit units, Palmer. So 360, 370 Fahrenheit is a pretty typical melting point for leaded solders. Tends to be a little bit higher for lead-free. Like I want to say like up in like a 390, 400, 425 range, but not radically higher. So that's the temperature that the solder itself is going to melt at. It's not the temperature that you're going to want to set your iron to, because of course, as let's say you set your iron to 365, and we just solder that melted exactly at 365. As soon as we touch our iron tip to our component, the component's going to start to heat up, and the tip's going to cool down, maybe to 250, 270, as it's dumping heat into that thing. But it's never going to get back up to that 350 degree temperature. You want your soldering iron tip to be set quite a bit higher than the melting temperature of your solder, so you can dump heat into your component, get it up nice and hot, put your solder in, it'll melt, and then cool back down. There are differences of opinion, let's say, as to what the best temperature for your soldering iron tip is for, let's say, leaded solder for hand soldering. I edge on the very high side of soldering temperatures. My default soldering iron temperature is 700 degrees Fahrenheit. That's way high. That's just the practice that I'm in. A lot of folks I know recommend like 450, 500 is plenty to get your components nice and hot, especially if you have, a soldering station that'll hold its temperature and really get you up to heat. That's kind of how I learned and I'm comfortable with. And I also know that like I am exposing my components to a really, really hot tip. So I have to manage my thermal load on my components so I'm not melting things. And that's a practice that I'm in, but I would say if you haven't, used a soldering station before, start out at 500, let's say, and you'll just get used to the amount of time it takes. You'll develop an intuition with your iron and the parts that you're working with. How long should I leave my tip on my components before it's up to, the temperature that it needs to be to melt my solder onto it? For me, it's a pretty short amount of time. Because I'm working with a really, really hot device. But for you, at a 500 degree temperature, which is, again, I recommend where you start, that's pretty screaming hot. You can also, as Kenneth points out, you can adjust the size of the temperature, not the size of your iron. If you adjust the size of your iron, I guess you could adjust the tip. If you adjust the temperature of your iron, you can sort of adjust how much heat is available to you. If I'm going to be soldering two big chunky wires together, the Heiko will go up to 899. I'll usually do 850. That just means there's more heat available. And I know if I'm soldering two big bits of copper, there ain't much there that's going to be damaged by high temperature. I'll just dump a bunch of heat in and get those two things soldered together. If I'm doing a bunch of really small components, I might go down as low as like 600, 550. Again, you could go lower, like 450 is perfectly reasonable. But you can mess around with your heat depending on what you're trying to dump heat into as you solder. Another reason that having like a temperature variable iron is super valuable, and that like those dumb soldering pencils that don't have any heat regulation on them are worthless for something like that. Yeah, temperature control. Chris says, what about mine is set to? Yeah, worth finding out. A lot of digital irons now also have a calibration ability. So you can, if you have a device that can accurately measure the tip of your iron, and Heiko makes one. I don't have one. I'm just relying on the factory default to be pretty good. you can calibrate your iron so that it's 750 on your display is actually 750. It's really easy, at least on the Heiko irons, to screw that calibration up by pressing the wrong buttons, and so your 750 might actually be 600 or 900. So I often just like reset the calibration on mine. So my iron could be plus or minus 25 degrees from reality, but I know that my 750 setting is the setting that I'm used to. So I just, I know that that's factory default, and then I just don't touch it. Yeah, exactly it kind of says. Like, it's not about what, like, 750 is better than 725. It's just like, oh, I need more heat, I need less heat. I know what my iron feels like. Certainly, like, at the soldering station that we had at Chicago Shakes, I found that I needed to edge it higher than I felt I needed to with my home iron station. That might have been because it had different tips that were less conductive. It might have been that the temperature calibrations weren't the same, or it had less thermal inertia. I don't really know. You sort of get to know your iron as you're working with it, and I encourage you to get to know your iron and work with it, because that's the best way to learn about how to make good solder joints. Let me do a couple more bits of through-hole soldering just to show you some sort of edge cases that you might run into, and then maybe we should talk about surface mount. As I transition here, there's been a lot of great questions that have gone by. I want to make sure that I haven't missed any, but I'm not scrolling back through. But as I said up here, if there's any questions that you have that I haven't answered, please shout them out again, because a lot of good stuff has come up. And like I say, I know we're kind of all over the place this evening, talking about safety and temperature and all these things, but that's just because it's a big integrated topic, and it's all important to talk about at once. Let's come back to the table here. Chris asked about cleaning the flux off your board after soldering. So it depends what product you use. If you're using a rosin core solder or a rosin flux, it's good practice to gently clean the rosin or the solder, the flux off of your board after you've soldered it. A little bit of water, honestly, if you're not working with anything that's water sensitive, is fine. Or a little bit of isopropyl alcohol. I have heard reports that isopropyl alcohol can cause either your solder mask, which is this part of this circuit board that doesn't take solder, or the labels to smudge. I don't typically see that, but that's just unique to my experience. I also, if you're not doing anything that you're hoping to last more than a couple of years, you can also just not worry about it, and just not bother to clean the flux off of things. You can also sometimes have what's called no clean flux. So these solder pens are no clean, and it just means that the agents in them are not going to be reactive enough for long enough that they're going to do any significant metal damage to your board, at least on the scales of a handful of years, which is all we typically care about. Some rosins in some cores are also no clean fluxes inside of your solder itself, but it's often unlabeled. Like, I'm looking at this Kester solder here, and Kester is a very reputable brand. I recommend them if you're looking at brands of solder. I don't think this one tells me. It says rosin core. Presumably, it would say no clean rosin core if that is a parameter that it has. I don't know that Kester makes a no clean rosin solder core, but they might. I have not seen. Palmer says softer / more pliable cables for your soldering irons make a huge difference. Yeah, it's true. Again, if you guys still like, here's my cable for my Heiko iron. It's nice and bendy. It makes things really easy to work with. If you have a really old, if you have a janky, no pun intended, Palmer, iron that's preventing you from getting your iron to where you need it to do work, you should get a different soldering station. All the AREA ones will let you, but they're all pretty good now. It's kind of like modern manufacturing has figured out how to make a cheap, pretty good soldering station. Let me show you a couple of little soldering things here, and selfishly, let me do a little bit of work on a project that I'm currently working on. So this is a little circuit board that I had made that's going to basically be a power injector for a DMX line. I'm going to take DMX in on this side, and I'm going to spit out DC voltage and DMX on the other side. I'm going to solder this DC barrel jack onto this circuit board. So one of the challenges here is that this is a much larger component lead than we've worked with so far, and because of the shape of these holes, you can see this DC jack has these little tabs that are a part of it instead of nice round leads. So there's kind of going to be a significant gap in between most of the parts of the component and the hole itself. You can see it hardly takes up any of that space. So let's solder that in place, and we'll show you a couple of tips. Couple of tips. Get it? Solder it's fine. So just like before, I'm going to come in with the flat edge of my chisel tip. I'm going to tin it just slightly, right, to get a little bit of solder on there. And then I'm going to start with these large clip components. I'm going to start at the point where the tab and the pad touch. So let's do this smallest one first over here. Coming in on a flat, I'm going to try and get as much contact area between my chisel tip and my pad and my lead as possible. So I'm going to pick the angle that my tip comes in to get a lot of contact between those three things. Come in sort of nice and flat here. Give that a hot second. I'm going to leave it a little bit longer than I would for the resistors to heat up. And then I'm just going to try testing it for temperature by just inserting my solder gently there. There we go. And I see it starts to flow, starts to flow, starts to flow. And we'll call that good. So now I pull away for a second here, and I can inspect to see how much solder did I actually get in there. You can kind of see I don't really have that nice doming effect that I would. I've screwed things up. I have kind of a janky angle going on here. So what I might do is apply just a little bit of flux with my flux pen. And I know that solder is going to flow nicely. Clean my tip just a little bit, retin it, boop. Retin my tip, and then I'm going to get my finger under there so that when I melt this solder again, I can just press that jack back into place. And I know because I have my flux on there that my solder is still going to flow nicely around that joint. There we go. Let's see. Barrel jack isn't surface mount? Yes. Yeah, so anytime you have metal protruding through a hole in your board, that is a through-hole device. We'll get to surface mount in a second here. Kenneth points out you can find a lot of things in both surface mount and through-hole. For mechanical things, especially things that are going to be mechanically plugged in by an end user, when possible, and it's not always, I like to hedge toward through-hole just for mechanical considerations. Because now I'm not only relying on the durability of my solder joint to make the mechanical connection between this part and the board, but I actually have this physical tab that's going to be preventing, if someone comes in here and like jams, someone, of course in this case being me, jams a connector down in there, they're not going to rip that DC jack right off the board. Sometimes that's not possible. Sometimes you don't have the space. Some components, like, say, a lot of USB jacks exist in varieties that are sort of have a through-hole support structure and a surface mount electrical connection. So you'll have some tabs that stick through the board that you solder in place that don't make an electrical connection, that are just there for reinforcement. And then you have some fingers that lay down on the board, and you solder those in place as a surface mount type part, and those are your electrical connection. And that gives you kind of the routing possibilities of a surface mount part and the mechanical stability of a through-hole part. Those are pretty common for USB connectors, HDMI connectors, things with a lot of pins in them tend to be. So there's our three little joints on our DC barrel jack there. I wonder, let me try a little experiment, because I'm really hoping we can sort of show some things off. I built a little riser earlier. Let's see if we can still focus. Hey, that's pretty nice. That worked out pretty well. So you can sort of see probably not quite as much solder as I could have, say, on this pin here. But you can see as I turn it sideways, we have that nice concave shape where that solder has really wicked itself right down into the tab there. That's very good. So that is the gist of through-hole soldering for something like that. I see Kenneth, I haven't read his, let's see, for cheap plastic connectors. Yeah, if you want your plastic melting, you can plug in a similar connector on the other side. So for this DMX, say Travis, I'll tell you about this part as I solder the next bit in. So I want to give myself options for how I inject DC power into this. So I also made it possible to put a terminal block on here. So I'm going to shove my 2 pins of my terminal block, and this is just a little screw device that you tighten those 2 screws, and that little clamp will clamp down on a bit of wire you've shoved in there. Those 2 are going to go through the holes in my board, and I'm going to be able to solder it in. So I designed this footprint so that it's a nice snug fit, so it's not going to fall out when I turn it over. But if it was in danger of falling out, you can always hold it in place with a little piece of tape. Just go bloop, tape over the top, and then it'll stay there as you solder it in. So again, I'm going to flip that over. This is a much smaller little pin and a much smaller pad, but that's going to be fine. For any through-hole work, your sort of standard chisel tip is going to be just fine. So I'm going to come in here with my flat of my chisel, get it pressed in there next to the pad. Get it nice and warmed up. I'm not going to wait nearly so long this time. Flow a little solder in there. And we have that nice concave shape. I'm right at the limits of where my camera will focus, but I'm hoping you can sort of see what I'm getting at there. Again, we'll do this side. You notice I didn't bother to clean my tip in between those two things. You know, if you're doing one joint right after the other, I often get lazy and just do a couple joints. A piece of guidance I've heard is, you know, if you're ever, when you're putting your iron back in your stand, clean it off then. That's a good metric for like how often you should be sort of cleaning your tip. Let's say... Oh, Palmer asked about trimming the leads on that barrel jack. I'm actually probably, if I was using a barrel jack like that because it sort of snaps into place, I'm not going to trim those leads. I'm going to sort of leave them as is. I could trim them with flush cutters. Like those would certainly make the cut. I might trim the leads on this header here, just with my flush cutters here. But for something big and mechanical, where I wanted to like not lose any strength like a barrel jack there, I'll usually just leave those, and that'll be fine. Palmer asked, when you designed this board, did you make a square pad or through? Yeah, so I did make a square pad and a circular pad just to like for orientation's sake. For me, the square pad kind of says pin 1 is pretty standard, which is true. For a lot of my power parts, pin the positive voltage pin, the supply voltage, I guess the supply voltage pin is square. That's true for all the footprints that I've made for myself. There's not really a standard for like necessarily for like header pins, but if you were to see a marked pin out of several, pin 1's a pretty good guess. That just makes it easier for me to like remember which is which when I'm placing them on a layout when I'm designing this circuit board. The Jeff standard, yeah, a lot of it. I mean, you know, we're talking at a level of like hobby electronics here, and which a lot of this comes from like me wanting to like make stuff for myself. I know a lot of people want to make stuff for themselves, but are also interested in repairing stuff that other people have made. And so it's a really good question, like figuring out what your own personal ways of working are. I'll make my face bigger. That's what I like to work with. What your own personal ways of working are, but then also trying to figure out how makers or manufacturers work in the world can be good, because then you can either adapt their standards or know what to look for when you're looking at a manufactured device. So it's a totally valid question. Travis, to get back to your question of what this board is, this is related to the miniature moving light project that I've been working on and off for a couple years now, and have revived recently. I'll use this as a transition to talk about surface mount soldering in just a second here. But the miniature moving lights, and for those who haven't seen them, I have a little semi-disassembled one here, which is pretty adorable, is this guy. It's a little DMX-controlled moving light, with DMX being the standard lighting control protocol in the industry. This is version 0.4. I'm currently building a version 0.8. Many differences, not too many of them mechanical, most of them electronic. The biggest is, instead of having to hardwire it into power in DMX, I'm going to a form factor where there is a 4-wire connector, a 4-wire header connector that just you would plug a little 4-wire wire into the back of each one. And those wires are, and I'm using some standards, ground, supply voltage, 12 to 24 volts, DMX plus and DMX minus, or DMX A and DMX B. And the DC ground and the DMX ground are the same, and I'm cheating because it's a cheap and tiny fun project. So I need a way to, combine DMX signals from a controller and some DC voltage into a singular cable. And so that's what this little breakout board is going to be, is a way to, to put a DMX connector on one end, or the 5-pin XLR connector, put my little header connectors on this end, and that branches out to the various lights. Chris is asking about scroller cable, and I've gone, part of the goal of this is for it to be cheap. Oh, can I get this without having tummy cam? Ab cam, as my wife called it? I don't think so, but I think it's worth it. Let's get some ab cam. Yeah, there you go. Hi. Oh my gosh, I like tummy cam. What I'm designing it for is to use. What I wanted is like I don't want to build custom cables for any of these things. I want this to be something that, like, I can buy for cheap, or anyone out there on the line can buy for cheap. So I'm using as a standard these little 4-wire cables that are meant for RGB LED tape. Because you can buy them for really cheap because they make them all over the place, and you can get 1 to 2 splitters, 1 to 4 splitters, all kinds of stuff like that. So that's the standard that I've chosen, just because it's like a cheap available connector. It's not a great connector, but again, it's not a great moving light, so like that'll be fine. Anyway, so that's the purpose of this board, is to basically combine a DMX signal and some DC power into one of those 4-pin connectors. And because I'm going to be doing experiments with them, I wanted a variety of ways to sort of put the power in, whether it's a power brick, or I use my power supply and shove a couple wires in there, or what have you. Yeah, 4-pin scroller cable is DMX data typically for most scrollers. Yeah, you have power plus, power minus, and then 2 lines of data. For like Wybron scrollers, it is DMX. For like CXIs and older scrollers, it's sometimes their own proprietary protocol. The nice thing about scroller cable, and for those who are not theater nerds in the audience, which I know is some of you out there, we're talking about color scrollers that would take a piece of colored semi-transparent media and move a strip of it past the front of a theatrical lighting fixture to change the color of that light during a show. The typical way of cabling them is you would have a lighting controller hooked up to basically a power injector that combines power and data into a single cable, and then you would daisy chain those through these various scroller devices, so they all were receiving power and data from a singular cable that ran in between them. Depending on the brand and the manufacturer and the date of manufacture, that might be the standard lighting control protocol, which is DMX. That might be something more proprietary that the power injector is converting to. But anyway, that's what we're talking about there. Nate asked, how did you get the board made? How many were made? Well, what a good question. I have my box of boards just here. So since these are experimental, I got a batch of 10 made from JLC PCB. Oh, not even. I got a batch of 5 made. Along with a few other boards, which we're going to transition to one of now, when we start talking about surface mount soldering. See, it's all one big segue. There are lots of good board manufacturers in the world these days. I will admit I'm not being very good. I should be supporting stateside suppliers. The one I should, of course, plug is OSH Park, which really was like the leader in low-cost hobby-level batch. Something strange is happening in my apartment, but I don't think anything's on fire, so I think we'll be okay. So sorry, just had a little dissociative episode as the whole world back around me came back into focus. That's totally wild. OSH Park, a great stateside manufacturer of PCBs at a hobbyist level. I use JLC PCB. You could use all PCB. There's various others. If you're doing like all of these are not manufacturing run style things. They are designed for, I need 3. I need 1 of a thing. I need 3 of a thing. I need 10 of a thing because I'm trying something out. I'm a hobbyist. I'm playing around. By the time you're making 1,000 or 10,000 of a thing, I mean, certainly like JLC or All PCB would love to be your manufacturer, but at that point you're probably hiring a contract manufacturer to make your product for you. These are meant to. So what these services do, and OSH Park really pioneered this idea, is a PCB manufacturer is going to be building their PCBs, their printed circuit boards, in large panels, 20-inch by 24-inch, 16-inch by 24-inch, something like that. That's going to be the size that fits in their machine. So they don't want to dedicate a whole panel to making a singular, just one of these. It's going to be a lot of wasted space and energy, or at least they're going to have to charge me an arm and a leg because they'll be wasting a lot of space to make just one little tiny circuit board. So what OSH Park did 10 years ago now, at least, was say, hey, hobbyist, send me your design. I'm going to panelize them for you. I'm going to stitch all your individual designs together into one panel, and then I'm going to send that off to a board fabrication house that's going to make, what is for them a full panel is going to be comprised of the various designs that people have sent me. And then when they're going to come back to OSH Park, they're going to snip them apart and send them back to the individual people who wanted them. And that was sort of the first example of like making PCB manufacturing at scale accessible to a hobbyist who really only wants, maybe one to get wrong, one to get right, and one to build for the final demo, right? I don't need 100,000 of these. I want just a few. So Oshpark have been doing this for a bunch of years, and as time went on and it was very successful, various other manufacturers picked up on this idea of, hey, offering hobbyist level runs of 1 or 3 or 5 boards or whatever. But Osh really did it first, and they're hugely helpful. If you're early in your first half dozen circuit boards, I encourage you to go through them. I remember a really pivotal moment when I was ordering my first circuit board, which this is not, but this was a very early one, where something was not coming out right in their preview service. You upload your files to the website to say, hey, I want to order this thing, and they give you a little visual preview of what it looks like, and something was not turning up right. I remember the owner of the company, Lane, emailing me, like, hey, you didn't turn this thing on that you're supposed to turn on when you output your files. I fixed it. Don't worry about it. You'll see your boards in 2 weeks. And that is the level of customer service you get when you're a really dedicated manufacturer. So worth supporting for sure. You also get these really pretty purple PCBs from them. That's kind of their trademark. Not trademark, but like that's their style, is these purple things. They look really, really good. So like I say, I am being a little naughty. I'm not supporting them like I should. So for that, I apologize. If they're watching, if they want to sponsor me, can you imagine? Oh, the day this has sponsors, we'll just... what I need is beer sponsors, clearly. But I would take circuit sponsors too, if you're out there. So dumb. So we'll do a whole thing sometime on designing circuit boards and how to order them and put them out there. I've done a little bit about that on this channel, like far in the past when this was not at all polished. I think Chris Wick had been there for a couple of, probably Kenneth too. But we'll do a whole evening sometime now that we kind of have a common vocabulary of, ways that we talk and ways that the stream is set up, and we'll talk about how you design and order circuit boards, because for something like this, I could build this circuit board, by hand. Like I could, solder some circuits together. I could figure out how to bodge that DC connector onto some perf board. That would be fine. For through-hole parts, it's convenient, but it's not strictly speaking necessary. For surface mount parts, trying to do surface mount parts on something like perf board is possible, but a real pain. So you're much, much better off getting a circuit board made if you're moving into the surface mount world. So... questions? I feel like I've just been rambling for a little bit of a time now. But shout them out if you have them. So I'll adjust my, let's see, full table there. We'll do this. What I should have been doing is cooling off my soldering iron, because I'm going to have to switch soldering iron tips here, which maybe I will show you the new tips while that other one is cooling a bit before it gets terribly, terribly hot. So, the tip of the soldering iron here, I said, has a sort of a chisel shape. Will you focus that close without burning my hand? Yeah, so we got that nice chisel shape. Question after SMD goes back to proto boards. Ooh, cool, awesome. Remind me. I'm sure I'll remember, but yes, that's a good. We'll come back around to that. So for through-hole parts, having that nice chisel shape that you can get nice and flat and touching all the components that you're soldering is really handy. But if I put this this chisel tip next to these pads here, you can see that the tip itself is as big as 2 pads next to each other. It's really inconveniently large for the work that we might want to do. And so we're going to choose a slightly different tip to work on those pads with. I bought a pack of 5 assorted pads to play with, 5 assorted tips to play with a while back, and they last quite a long time. I have a couple of broader chisel tips, right? So if we were working on a really big bit of wire that we needed to dump a lot of heat into, I could use a fat chisel 1, extra fat chisel 2. I have another standard chisel, like in case my first one dies out. This one is a little bit more conical, maybe slightly smaller chisel. Where are we there? Yeah. That's more of a conical tip. You could use that if you wanted to. These are really the 2 tips that you're going to use for surface mount work with a very, very fine point. One is straight and one is sort of angled there. I know a lot of people like to use this angled tip. I have just gotten used to this straight conical tip here as the tip of choice, but again, like I say, a lot of people really like this sort of bent hook tip here. And you can get all these varieties and a lot more for just about any soldering iron. This is not unique to Heiko. Just make sure if you're ordering some, you get the tips that are sized for your soldering station, because they're not all interchangeable. So, let me zoom this out here. Because I didn't let my my tip cooled down as I was talking. I'm gonna have to do this a little bit hot. But almost all these soldering stations work the same way. If you want to change the tip, you'll have a collar down here that unscrews from your handle. So I'm gonna unscrew that with my pliers here. That will lift off. I'll take that off. A little hot. You'll have this cover here. I take that off, and that exposes the tip of my iron. All right, I'm going to take that tip off. And inside, we see the actual ceramic heating element that we're dumping heat into using the electricity from our base station. That's what's actually heating up and passing its heat into this hollow tip here to create heat to actually do our soldering with. So I'm going to set that tip aside. You might be able to hear it sizzling in my drawer there. So I'm going to put my new tip gingerly on. I'm going to put my cover back on. And what I've noticed is these tips, though they're in theory sized for Heiko, are just a little bit off-brand. So the collar doesn't thread on quite as far because the tip is just a little bit longer on these ones. But as long as I get a couple threads on there, I'm not too worried. Let's see if I can do this with pliers under the camera. That went pretty well. So now I've screwed that on pretty tightly. That should be fine. Stick that back in my stand. I'm going to turn my iron back on. And I'm going to leave myself at the same 700 degrees that I was at earlier. And just to kind of show you how solder size is affected by, how the soldering process is affected by the size of the components that we're working with. But this would certainly be a situation where turning down to like 550, 600 would be totally normal. So Lee's been taking a drink every time Jeff says tip. Now, yeah, there's a lot of tips in this evening. I hope you found the tips useful. That's like this. You take a drink every time I make that exact same pun. You would be wasted. Ooh, Bodum. Let's see here. So I guess I haven't looked at surface mount parts before. Hopefully the name makes them a little bit clear, but they are parts that sit on the surface of your circuit board rather than protruding through a hole. So you can see this is the outline. I need a pointy stick because I'm so zoomed in. Here we go. So you can see I'm going to put an IC here in this outline. I'm going to put an IC here in this outline. They're going to sit on top of these exposed pads, and I'm going to solder down to them. One really useful thing that you get on a circuit board that you don't get on perf board or proto board is the little, you can see this little green divisor, this green covering that's all over everything, but especially between these pads. That's called a solder mask. It is there specifically, is a thing that solder does not stick to. So as we are soldering these things together, we're still going to have to be fairly careful that we don't, blob a bunch of solder on here and bridge everything. But the material that sits in between those exposed metal pads is going to tend to resist solder sticking to it, which is going to be really, really helpful for us. Obviously, on something like a proto board, you just have exposed pads and plastic. Now, the solder's not really going to stick to plastic, but neither is it going to be repelled. So now I'm distracted by Kenneth. Someone forgot to renumber their parts after adding the SOC. Oh yeah, for sure. Yeah, Kenneth, this is version 1.1 of this board. Kenneth's referring to the fact that I have IC1, IC2, and U1. So when we talk about circuit boards, we'll talk about part labeling. But and there's a variety of ways you can do it. But I have this integrated circuit, this chip 1, chip 2. Really, this should be chip 3, and I just forgot to change the label on it. So that's going to be labeled as another thing number 1. Oops. Like I say, these are mostly just for me. So because we don't have, we have less surface area to work with because, as you can probably tell from the camera, these are quite a bit smaller, and we don't have that sort of reverse side to come through and solder from. We're going to have to take do some special things to get these soldered. I'm just going to make sure this is really nicely tight in my vise first. That'll help. And let me grab some parts. Let's see here. Yes, so let me grab. So this is what the parts look like. When we talk about circuit boards, we should talk about circuit board assembly as well. When have we ever gone off the reservation before? That's never happened in the history of Electronics Bash ever. But just to show you, this is something like what the parts would look like when they show up to you from DigiKey. They're in an anti-static bag that literally prevents static electricity from coming through because static electricity can damage integrated circuits. we have a little cut tape here, this little flexible package that all these chips are sitting in. This is a bit of packaging that's meant to be fed into an automated machine. That sort of, you can see these little holes along the side like an old dot matrix printer. The machine would feed the parts in, pick them up, place them on a board, and solder them for you. So when you order, only 10 of them instead of 100,000 of them, they just chop a little bit off of one of those reels, put it in an envelope, and ship it to you. So I'm going to peel back the tape here that's holding them in, take out my little part, and this is going to be the little tiny parts that we solder in place today. Now, I don't want anyone thinking like, hey, we're getting really, I don't know if I can do this. You can absolutely solder surface mount parts. I 100% guarantee it. It takes some practice, and I have a tip on how to practice for you. But it is not, I have a tip. Is that even worth, it's the same joke. It's the same joke over and over again. But it is really not as hard as it looks, especially something like this is not a terribly small surface mount part. As these things go, you could solder this today. If you've soldered anything before, you could certainly solder this. So first thing I'm going to do is I'm going to line up my part in the, I'm going to drop my part. The second thing I'm going to do is align my part in the proper orientation. The designer of this circuit board, me, put a little indicator right there, that little sort of notch symbol to indicate where pin 1 is. And as we talked about last week, pin 1 is either indicated by a notch on the side or a little dot by pin 1 in this case. No, Palmer, these are not ceramic tweezers. These are just Amazon tweezers. Just a cheap bit. I should say, so I sort of threw out that like static electricity can damage integrated circuits. At the level that I'm working at with relatively inexpensive chips, I typically don't bother. Like, to be most proper, I should have either a wrist strap or a boot strap that's grounding me at all times so I can't develop static electricity. For a hobbyist, I don't worry about it. I don't know that I have ever damaged a chip in my workshop. Although I do notice, like, if I'm having a really staticky day and I'm like wearing a synthetic shirt over a cotton shirt and I'm getting really zappy, I'll go change that out for something that's not going to be super shocky. But other than that, like, I don't bother grounding myself in my workbench. I'm not working with anything that's that expensive or typically that fragile. So I'm going to take this, and I've got my pin 1 dot here. I'm going to line this up in the proper place, just close, just so I know where it's going, and verify that I got the footprint right before I start soldering it in, and I did, which is good. So what I'm going to do here, I'm just going to move that out of the way, and I'm going to do a thing that's going to be a little bit counter to what I told you earlier, which is, put the parts in place and then solder them. Don't bring the parts to the solder. With something this small, what I really need first is a way to just get this part to stay in place while I solder the rest of it. So what I'm going to do here, and I apologize if it gets I can get a little bit closer, get a little bit of an intimate top of head view. I'm going to take this, get my tip really nice and clean, and I'm going to apply just the tip here. I'm going to do a little bit of solder on this pad right here, just because it's in a convenient place for me. A little solder just on there. Boop. Just a little dot of solder just on that little pad, right? Now I'm going to take my tweezers, and you could do this by hand. I just find tweezers really convenient. I'm going to move that chip over to that position, and I'm going to apply my iron and reflow that solder. I'm not going to bother with flux at this point, just get it held in place. And now I'm going to do a quick visual inspection and say, is that chip where I want it to be? It's not quite. I wish, you see how this side is just a little bit shifted in this direction? So I'm going to, while I only have one pin soldered down, I am going to just take this and reflow. And like I say, I'm not going to be super duper concerned about cleanliness or adding flux at this point. I really am just using that solder as a glue to get this in the right place. Now I am doing this just by eye because it's a fairly large part. I'm being a little hindered by the presence of all the cameras here. But you can certainly be aided by magnification, either like a head-worn magnifier or a magnifying glass. There are many kinds out there. Here's a really derpy looking one that I use. Oh, that doesn't go over my headphones. But I'll show it to you. It's this guy. This was like $12 at I think a Radio Shack, with a couple different levels of magnification there. It looks super, super cool. Impress your partners, impress your friends, but it's not necessary really for a part this size. So now I've got that one pin tacked down. I'm just going to inspect and see, are all those other pins lining up as best as I want them to? I think I'm a little bit off center that way, but I'm not going to worry about it too much. So now that I've got that in place, I'm going to clean my tip on the other side here. I'm going to bring my iron in on the opposing pin, press my soldering iron into the junction between the pad and the leg just as before. Apply just a tiny bit of solder and pull my iron away and inspect and see, yeah, that is now a nicely soldered leg. And now I have two oppositely connected legs here that are going to hold that chip really firmly in place as I solder the rest of the pins. I'm going to actually turn this sideways just to make it a little bit easier to access for me. If we can still see it, yeah. Partly it's because I'm right-handed and I like to come in parallel to my legs with my iron here. Can you still see everything? I think so. And then I'm going to come in sort of over the top with my solder. So pressing the tip of my iron into the junction between the pad and the leg just as before, touching my solder to the joint between the two, and making sure that that flows really nicely. There we go. Pressing my tip in. I'm getting my tip, it's a little hard to see, I'm getting my tip very flat to the board there, so that the sort of the long side of it is touching the exposed pad, and the tip of it is touching that very, very thin component leg. Cleaning that tip off really well so I don't have any old gummy solder on the tip as I come to do the next joint. There we go. Getting the solder in just sort of next to the iron there. Getting that leg in place, and so on. Not all these are perfect solder joints. You can see I have a little bit of a mohawk, just a little bit of a guy standing up off of that one, but I'm not too worried about that. Again, this is a board just for me. I'm not going to worry too much about it. I'm just going to go around like this through all of the other legs. I have to make sure that they are all properly soldered in place. Now, one thing we haven't talked about is what happens if you screw up? How do you get yourself out of a jam? So I will show you. Let's screw some things up on purpose this time, and then we'll get ourselves out of it. So let's say I'm having a brain fart, and I'm soldering away and also talking to Lee and Chris and Kenneth and Nate and Katie McBee and whoever else on the internet, and I flow a bunch of solder in between these two legs, and I bridge them. You might be able to see there. I put it back in the light a little bit better. You can see I've blobbed a bunch of solder and I've created a bridge between the two legs of this integrated circuit here, which is probably not what I'm intended to do. How am I going to get out of that? The tool I like best for this situation is solder wick. Solder wick is great. This is something Kenneth was alluding to earlier. I think Chris asked about it too. Using flux with a solder wick. Solder wick, if you haven't played with it before, is a braided, typically copper ribbon that is meant for the removal of solder from a surface. They often have, some of them have flux impregnated in them. Some of them you would apply flux to. I think a lot of them have flux in them these days. But the goal is, so we said earlier that solder, when you apply heat to it, likes to suck down into crevices, likes to get shrunk down. Its surface tension tends to make it fill holes in gaps of things. So we're going to use this ribbon, this woven ribbon, which has a lot of surface area on all those various copper threads. We're going to use that to basically soak up the solder from our surface as we go. Now, if I was doing a big, like I need to suck a lot of solder on it, I might switch back to my chisel tip. For a little boo-boo like this one, the conical tip that I've got here will work fine. So I'm just going to clean my tip off really well. I might tin my tip just a little bit here just to help it make really good thermal contact. Boop. There we go. So a little tiny bit of solder on there. I'm going to take my solder wick, or my super wick, as this brand calls it. I'm going to put it right over the top of my problematic area. I'm going to lay my soldering iron down right on top of it, and I'm going to let the heat pass through the copper down into my solder and soak all that solder right away. You can see that solder has ended up on the wire there. This one I can tell has flux inside it because as I pressed down into my part, it started to smoke and sizzle just a little bit there. That's the flux inside the wick evaporating and being used up. Now, because this is now full of solder and has flux all over it, this is now used up. So I'm going to trim that off and leave a fresh end for myself next time. Now, most of the time I find when I'm doing, touch-ups on little surface mount parts like this, you sometimes end up with just enough solder left for there to still be a good solder joint on your part. But a lot of the times what you'll end up with is you need to go back in and redo those solder joints. It's actually not ever a bad idea to just touch up, make sure they're actually still soldered. Boop. There's one. Boop. There's two. So it's just that solder wick is miraculous stuff. It's really, really good. Palmer asks, does soldering paste work with an iron? Oh, hilariously, I I don't know if any of you follow Great Scott, the YouTube channel. He is a great maker and electronicist. He released a video today about various ways to reflow solder paste, which is a flux and solder mixture into sort of a paste-like material. He looked at using a soldering iron, a reflow oven, or hot sand to reflow solder paste. Go check his video out. He's at Great Scott Gadgets, I think is his channel. Really good explanation of using solder paste at home, which is a really coincidentally neat video to come out today. Palmer asked about solder suckers. Yeah, so here's my opinion of solder suckers. I think is captured by the fact that knowing that I was doing a talk about solder this week, and we're going to talk about solder on a Sunday night, I've been looking for mine. I don't know where my solder sucker is. I'm not that sad about it. Let's pull up a solder sucker for those who may not have seen one before, just so we all are on the same page. But I think they have a very specific use. So this is a solder sucker. Show me that sucker. Show me that thing. Can we see that all right? Yeah. So it is a small plastic device with a plunger in it and a spring. You depress the plunger all the way down in, it locks in place, and when you press this little button, the plunger is released, sucking air up through the nozzle, and if that nozzle is placed over a bit of hot molten solder, the action of that plunger withdrawing is meant to suck that molten solder back up into the device and clear it out. The use case, like the only thing that they're meant to be used for is clearing out holes through holes on a device that you're trying to get solder out of. So, for example, let's say, here, let's come back so you can see it. On this, awful Frankenstein of a device, as I was soldering this resistor in here, I got some solder accidentally into the adjacent hole, and that's not ideal. Or, let's say I needed to desolder this resistor entirely, and I pulled it out, and there was still some solder hanging around down in there. I need it to be gone so I can get the next resistor, the replacement part, back down in there and solder it in place. A solder sucker is meant to clear out solder from an unfilled through hole, and that is it. They're not for removing solder from surface mount parts. They're not for removing solder from anywhere else, but for clearing through holes. And for that, solder wick works pretty darn well. Unless you have a really thick surface board or a really thick stack up, I just use wick. Kenneth makes a fair point. They're really dirt cheap. Like $6 or $7 is a perfectly fine price to pay for them, and they're all pretty much the same because they're all pretty bad. So get one. It's sometimes useful if you have to clear a lot of holes. Like if you were, I need to replace all the wires that are coming out of this board that are all through hole. Maybe it's the perfect tool. But there is it does take some practice to like get used to where do I put my iron to heat up that solder. Then you get the sucker in there and then press the button. I often end up coming at them from opposite sides. So I'm heating the solder from the hole from one side and getting the sucker in there from the other and slurping it out that way. Kenneth likes his, and that's great. It's worth playing with. They're totally cheap. I just find that, like, for what they are, they're fine. I just find that wick is going to be easier for a lot of things that I do. But worth playing with. The advanced version of this tool that you could also use, and I don't know that I think I did not pull a picture of this. Yeah, is a desoldering gun. So we'll do Amazon together. Desoldering gun. So a desoldering gun or a desoldering iron or a desoldering tool, and Heiko makes one. So if I ever get one, I can get them in color coordinated versions. Looks something like this. It is basically a soldering iron itself with a hollow tip and a vacuum pump inside of the device. So what you're meant to do is place it down over either a hole that has solder still on it or all the way over the lead of a through-hole component. You melt the solder using the hot tip, then you activate the vacuum to suck the solder right off of it, and then you can just pull your part off. I have never had a great experience with a desoldering gun. Now, I've never bought a really name-brandy one. The cheapy ones I have used have been fine, hit or miss. But again, like with wick and a little bit of work, I find them to be, not really worth the cost. This Heiko one's $250. That is too much to pay. You can get them for $60 or $70. If you ever have one in your workshop, try it. Maybe it's the perfect tool for you. I find them kind of cumbersome. and things you could do with solder wick anyway. But, you know, if you're a person who is specifically salvaging old mixer diodes out of old radios, maybe you do want to invest in a tool that, you know, specifically clears away solder from leaded components really easily. Like maybe that's the perfect tool for you. For the work that I'm doing nowadays, that's not the tool for me, but maybe it's something you want to use. So something that's worth thinking about. Let's see. Lee, man, if you're taking purchasing advice from this channel still, we are in trouble. Palmer points out we're coming up on 90 minutes. Yes, we certainly are. Let me talk just a little bit more about surface mount components, and then I want to run through my list real quick and make sure I haven't forgotten anything. So the techniques of surface mount soldering for a lot of parts is essentially get one pin in place, tack it in place, and then move across all the other pins, soldering them down. So you'll notice that I've got some integrated circuits in here, and then I have some little passive components. I got C2, R1, R2, C1, C3. Those are little surface mount resistors and capacitors. So let's see here. Those will come similarly to the way that the integrated circuits came in packaging that's meant to be fed into a machine. If you buy surface mount resistors, they will similarly come attached to a piece of tape like this, that's sort of cardboard with tape on top of it. It's meant to be fed into what's called a pick and place machine that picks the components off of them and places them onto your board to be soldered in place. So this, if you're doing a surface mount board, you can not only do integrated circuits, but you can do passives like this as well. I'm going to try and take this one resistor out without flinging it everywhere, and I think I have, which is good, just off camera down here. These guys can get really tiny. So this is actually not in this grand scheme of things that small. So that is a little 10 kilo ohm resistor. If I put it on the tip of my finger, see, it is not terribly big, although they've still managed to squeeze labeling into it here. This one, what does the labeling actually say? 10K. That's a 10K resistor right there. Let's see. So I just want to show you how you can solder something like this in. It's a little bit tricky, and then I want to come back to that tip about how to learn to solder surface mount devices, and then I want to come back to Chris's question about protoboard, and then we'll do something else, or we'll go home and drink, or we'll go home. If any, I mean, maybe not everyone's at home, but I assume a lot of you are at home, because where else are we these days? So the soldering of these parts is a lot like the soldering of the integrated circuits. So what I'm going to do, let's solder in. Let's see. Let's do something on this side, because I know these are all 10K. This is a little dip switch driver board, I should say. Each of the switches needs a pull-down resistor over on this side of the board here. So I might as well solder one in place and kill two birds with one stone tonight. So much like with the IC, I'm going to come in with my tip, and I'm going to just apply a tiny bit of solder to one of the pads. Let's say I'm going to do this first resistor down here. Put a little bit of solder there. There we go. It's got a little bit of solder on that side of the board. Now, because surface mount resistors are so much smaller and a little trickier to work with, I am going to apply just a little bit of flux there to make my life easier. And then I'm going to come in, I'm going to pick up my resistor with my tweezers down here off camera. Boop. Bring that in there, and then I'm going to come in with my conical tip. I'm going to sort of press that resistor into place, and then just melt that solder right up against the resistor until it stays. And again, I'm not super worried about it being a great solder joint right now. I really just need something to hold that resistor in place while I solder the other side, and then I can come back and reflow that first side. So now I'm going to come back over here. This is the unsoldered side. I'm going to press my tip into the joint there, apply a little bit of solder. That's pretty good. And now, just because I'm not confident I did a great job joining that first side, I'm going to come back around to the first side, take a little bit of solder, and just tap it right into the joint there. And that's a surface mount part soldered in place. So this particular resistor is what's called an 0603 resistor, or 0603 surface mount part. That refers to the dimensions of the part in thousandths of an inch. So an 0603 part is 6 thousandths long by 3 thousandths wide. Here's a little gotcha specifically about 0603 and 0402 parts. So Service mount parts come in all many different sizes. 0603 is relatively small. You can imagine if we had an 0402, it would be even smaller than that. They go down to 0201, and they also go up 0805, 1210, 1612, something like that. And they just keep getting bigger from there. 16 thousandths by, what did I, centi-inches? Oh, yes, 0603 is 60 mil by 30 mil, not 6 mil. 6 mil will be very tiny. So that you can tell the dimensions of your part by the name of the size of the part. The gotcha that I wanted to talk about, though, is so most parts will be listed by their JDEC standard size, which is an imperial size. There are also parts that are made or referenced in metric sizes, which are referenced in, I think, tenths of a millimeter. So they are fairly different sizes. If you compare 10 centi-inches, 100 mil to 10 to 1 millimeter, you have about a 3-to-1 compression ratio there. So a part that is 100 mil wide and a part that's 1 millimeter wide are pretty different sizes, but the names overlap. That's the takeaway. So if you get an 0603 imperial resistor, it will be this big. If you get an 0603 metric resistor, it will be about a third of that size, and you'll be really sad because that is just frankly too small to solder. There are only a few names for which the overlap actually happens, 0603 and 0402 specifically. The other ones, like the imperial might be 1612, and the metric might be 2416, and they just won't necessarily have the same name. But if you're ordering parts, make sure they are in imperial dimensions. If you search on Twitter for metric 0603, and you'll see lots of people being like, oh, I have a tiny resistor that now I can't solder. I need to put an order in again. It's a lot of fun. But surface mount parts, it may seem intimidating because they are quite small, but you can totally solder this. You can do 0603. I can by eye. For 0402, I like to use magnification for that just because it's a little bit more comfortable doing it at scale. But here's that tip for how you can get started soldering surface mount devices if you never have before. What I recommend is go to Amazon or eBay or your vendor of choice. And I know we should be trying to support local and try to not support giant corporations who do bad things as much as possible. So choose one responsibly. But get yourself a little surface mount soldering kit. These exist in many different kinds from many different manufacturers, specifically for those who want to practice their surface mount soldering ability. Let me spin. How do we do this? Spin that there. So what this is, this came as a kit that has a circuit board included for you, and a large number of places to solder surface mount devices in a variety of sizes, and a bunch of surface mount parts for you to practice soldering on. So you can see they've actually labeled it nicely for us. I've got a 1206 size resistor, a whole row of those to practice on. I have an 0805, a couple different rows of those to practice on. 0603, 0603, and 0402, if I move that down here so we can actually see. And they've set it up in such a way, so once you've started all those parts in, and all of the various parts are in the middle here, which are some resistors and some diodes and some integrated circuits, if it's all soldered in place correctly, you get a little cycling light. You get like a little, chaser car light that flatters around. And if you haven't, it's a good opportunity to go back and figure out where things have not gone right. Mostly, it gives you a chance hey, I'm going to practice soldering, 10 of this, 1206, and I do 20 of this 0805. It's just a really low stakes way to start getting yourself exposed to soldering surface mount devices. And what's funny is once, a 1206 is a relatively beefy part compared to the ones we were just doing. It's a great place to start practicing, and you just build skill and build confidence at a larger size, and then you just step down to a smaller size, and you go smaller and smaller. 0402, the smallest size that's typically on these practice boards, it's pretty dang small. I don't put them on projects of mine that I'm planning to hand solder just because they're too annoyingly small. I will do 0603 parts because that is about the smallest size that I can sort of comfortably do. But, it's oh, I got this kit in the mail. Can I solder this 1206 part? Well, I will just apply my soldering iron to one pad, get a little bit of solder on there, take my part in my tweezers, This process, I will say, is a lot easier with tweezers. You don't necessarily have to have them, but I find for heat's sake, keeping your fingers out of there is really helpful. I'm going to get my iron in there and just sort of tack down one side of that resistor. There we go. I'm going to come around. I'm not even going to spin it this time. I'm just going to come around to the other side of the resistor and flow my solder in there. I should have waited a moment longer before I put the solder in. It was not quite hot enough. I'm going to come back to the first side, get it hot again, tap a little more solder on there. Ooh, and you can see I should have waited a little longer because that resistor ran away a little bit, but we managed to salvage it. You just go down the line. Just, that's a really good way to, practice your SMD soldering or like build confidence in it. Because I swear you can do this. This is a really great way to practice. This kit was like $6. So Lee, there's another thing. Call your credit card company. Tell them Jeff Glass has one more purchase, and will they unlock your card to do just one more thing. Let's see. Palmer said, how long can you heat the second side before the first side will reheat and melt? You could do a fairly long size. A fairly long way. So this is, so Palmer's referencing that this little resistor here says 203. So the codes on surface mount resistors are typically 2 digits multiplied by 10 to the power of the third digit. So 203 is 20 times 10 to the third, or 20,000. That's fairly standard. Sometimes, the other one just said 10K. That also happens. But that is the standard for labeling of resistor codes. So anyway, if you're interested in getting into surface mount devices, I encourage you to order one of these kits. I think I linked one of them in the description if you want to get that one, this specific one. I built this one a couple of times for various projects. You also get this like cool reference on the back that shows you a little bit about, hey, here's how big the various parts are. Here's a little ruler for you to reference. And then here's various widths in both mil, which is hundredths of an inch, and in millimeters. And this is meant for judging how thick your traces on your circuit board should be, your actual connections of copper on your circuit board should be, just to give you some size reference. But that's just a little fun thing they include there. Yeah, that is the gist of surface mount soldering. The technique I'm not going to talk about tonight is called, not wave soldering. Why can't I think of it? Drag soldering. So there is a thing called drag soldering, which is basically, I'm not going to do it because I'm bad at it, where you put your component in place, you get some solder on the tip of your iron, and then you just drag the solder across the pins of your IC, and it's supposed to stick to each individual pin in turn and not to each other. I've never had great success with it, but apparently it's a thing you can do if you're really good. You can get special tips that make it easier to have kind of a bowl in the end of the tip. Ken says he mainly uses drag solder. That's fantastic. And also, maybe I'm just not using the right tip. I also haven't tried it a whole bunch because I'm kind of lazy. But yeah, Google drag soldering or check out some videos on it. I know some YouTubers have done some tutorials on drag soldering. If you're doing a lot of little fine pitch surface mount ICs like this, it could save you a lot of time. Surely it would save me a lot of time, that's for sure. But like I say, I'm not bad at it. Also not talking about solder oven or bath. Yeah, for sure. We'll talk about assembly methods for circuit boards the night we talk about circuit boards. Because it's sort of meant to be, it's hard to talk about soldering without talking about circuit boards, but we'll see if we can, we're coming up on 90 minutes, so I can tell where we are. I just want to stay on topic a little bit here. Said no one on this channel ever. Chris, while I'm putting this away, what was your question about proto boards that you so kindly held in your pocket until later? I stick this back away. I will say these kits don't always come with great instructions, but you can pretty much figure out what they're supposed to be from the labeling on the boards themselves, which is nice. Ooh, I didn't put my safety glasses on. I told you I'm awful about this, and it was scary to get soldering right there. So I really should be better. So be better out there. Everyone out there, be better than me. Would be good. Let's see. Palmer says, can you do a quick demo of ways to solder two wires together? I sure can. And Chris says, how do you make traces on proto board? I get this resistor connected to that capacitor. Yeah, let me do a let's see, who shall I do first? Palmer, I'm going to do a wire soldering demo first, and then Chris, I will show you thoughts for making traces on proto board. So I am going to switch back to my chisel tip for this, just because it'll make life a little bit easier. And again, I've managed to not burn myself at all this evening talking about soldering irons, which I feel pretty good about. I'm sure Mary feels pretty good about it too, my wife. And my dog, because I need my hands to scritch her, which is the only purpose, and feed her, I suppose. Those are the two things that I'm good for as far as she is concerned. Let's see here. Oops. A little schmutz there. All right, we'll get that screwed back on. And I will show you actually 2 different ways of joining wires together. One which is my favorite for stranded wire, and one which is really more appropriate for solid core wire. All right, let's turn the soldering iron back on, and let's come back to the table, and we'll zoom out a little bit here. Boop. So we can see everything. Let me get a couple of bits of wire here. All right, so let's say you're attaching, let's do solid core wire first. We'll do let's 2 bits of solid core wire. We need to attach them together. How are we gonna make a nice soldered solid electrical connection here? Oh, Palmer, what a good question. Kenneth has opinions about tinning wires in headers, if you want to share, Kenneth, while I do this demo. So this connection is going to be called a Western Union splice, or a linesman splice. Western Union, like the telegraph company, who was in the field splicing together wires for telegraph lines. So what you do is snip off, maybe a couple inches of wire. I'm going to do maybe, this is a fine core 20 gauge bell wire here, so maybe do a couple inches. What I will do is cross them over each other like so, and then bend them at a 90-degree angle so they sort of interlink like that. And then, I find it really helpful if you hold the joint in pliers for this next part. I'm going to take one of the wires and wrap it around its twin really nice and close and firm. You really want those turns to be sort of next to each other if you're doing this really cleanly. That's okay. So you can see I've got that spiral of wire next to each other. And then I'm going to reverse my hold, grab the center with pliers, and similarly I'm going to twist this wire around itself. Now, according to Western Union, this actually in the field would be a pretty decent splice of 2 wires that were carrying a telegraph signal, but of course we're at a workbench and we can solder it. So I'm going to take a bit of solder, apply that to the joint between the 2, and in theory you can get these to space out a little bit if you'd like to. One of the benefits of this splice is that if you do it right so that things are tight but not super tight, the wires can slide along each other just a little bit. That sort of spiral section can slide forward and backward on the other wire, which gives you a little bit of variability for like the shrinking and growing of wires in the heat of the sun if you're a telegraph company, let's say. For our purposes, we're going to want a fixed length. So now I've applied solder to that, and now I'm using the mechanical strength of the copper to hold that junction really solid, as well as the solder there. So that's the solid core Western Union junction. Also called the linesman's junction, also called the NASA junction, because that's what they sort of recommended in one of their sort of famous style guides. For stranded wire, there's a couple of things you can do. Let me snip off a couple pieces of stranded wire from the box here. Yes, I see. I knew Kenneth had opinions about, because we specifically had a back and forth about this not that long ago. Yeah, so in theory, header connectors are meant to, compression connectors are meant to be used on untinned copper surfaces. I've definitely have been in situations where, given the inability to change the wire or the stupid header connector, using a bit of tinning as additional mechanical reinforcement for the wire was preferable. Really, that it's not the right tool for the job, right? There should be other ways to do mechanical reinforcement, but in a situation where you can't apply, say, additional glue, or maybe you don't have room to put a ferrule on there, having a bit of tin, a bit of solder on your wire, I think is acceptable, but that's just me. That I cut off wasn't stranded wire, so that's not going to be a very good demo. Where have I got some stranded wire? Let's see here. Tummy cam. Alone in the world with the tummy cam. Let's see here. I'm going to snip this in half for a project tomorrow anyway. Back. I'm just going to use a couple bits of this yellow stranded wire here, which we'll strip back. This is way more than I needed to strip back. That's a little bit silly, but for the sake of explanation. So here's our 2 bits of stranded wire that I've stripped back here. So you could do a Western Union splice on these 2. It's a little bit finickier to do with stranded wire, but that would probably be your best option. What I often do is take the 2 bits of wire, give them a little crimp at a 90-degree angle, interlace them through each other, and then fold back. I've basically just sort of hooked those two together like a pair of elbows hooked over each other, and then just apply a little bit of solder at that joint. Now, if you were doing this for realsies, you wouldn't need to strip back nearly as much wire as I did here. This is kind of overkill. But now I've made a sort of a nice electrical contact there. What I lost by not doing the Western Union splice is, of course, I have no mechanical reinforcement here, but I'm, can be pretty confident of the electrical contact between these two. And of course, if you were doing this in the field, or for a portable installation, you'd want to use some Tommy Cam. No, you'd want to use some heat shrink, which most of you will have seen before. Just a heat shrink plastic that you apply hot air to after you slip it over your wires here, that shrinks down and sort of encases that in a new layer of insulation, so it's not shorting on anything. I have enough Tommy Cam that can live on the floor until further notice. Let's see. Palmer, does that answer your question? So those are the two methods that I use: Western Union splice, sort of hooking those two things together, and sort of bending the two wires together and soldering them together. Ooh, thanks, Nate. Thank you. Yeah, 12 viewers. How cool. It's funny. I don't look at the statistics or anything like while we watch this, just because like I'd rather just talk at you and like hear what's going on. But that's really cool. Yeah, feel free to like and subscribe. We're at 99 subscribers. It's neat. I'm not here for the numbers, but it's cool to share this with people, and it's been cool to like meet new people and see old friends. Like it's been really neat. Let's do Chris's question, because I know we're coming up on 90 minutes. And then we will call it, and we'll talk about what we're going to do next week. Making traces in a perf board situation was your question, Chris. So Chris, obviously one of the options you have would be to, let's come back to the table here, would be to use a product like this proto board, this perma-proto style thing that has these traces already built into it, right? So if we were to attach where's the chip? If I were to put a little through-hole chip on there, and I started that in place, the legs of this one would be connected to sort of that long trace running off that way, and this long trace running off this way, and I could use that to make my connections. That would be one way to sort of have traces on your proto board. But I think what you're asking about, Chris, is something more like this monstrosity. If I had to connect these resistors to each other, or some other circuitry, how would I do it? It's like, what's the way? I will show you. I should say, as I'm getting stuff set back up here in this circuit holder vise, I linked to this one in the description if you like it. I certainly do. I also use a 3D printed version for a long time, and I put the Thingiverse link down there if you want to check out 3D printing your own work holding vise. That works actually really well for a 3D printed part. I then threw it in my work bag one day and snapped it in half, but you would probably do better than I would. Chris says, connect all those resistors together? Yeah, and then we'll put 120 volts across them and just see what happens. And we'll be Electro Boom, I guess. So, let's see. What's going to be a reasonable way to do this? Well, one thing that's nice, I haven't trimmed these at all yet. So one way that you can make connections between components in a perf board situation, and I'll zoom back in here a little bit. There we go, is just use the legs of the components themselves, right? So let's say that in my circuit I needed this leg of this resistor and this leg of this resistor to be connected together. One thing I could do would be to take their exposed leads on the back here, cross them over each other, and solder them together at that point. Now you want to make sure they're making firm firm physical contact there, because one thing that solder is not really good at is bridging gaps. It really wants to be stuck to a surface. But as long as those two are touching each other, I can take my chisel tip here. I'm going to wet it a little bit. I'm glad I remembered to turn my iron on. That's a first. Touch that there. Get those wires nice and hot. Apply just a little solder. And now those two are soldered together. Right, and now as they cool, I can come in, I can snip off that leg and that leg, and now those two resistors are connected together underneath the board there. So that's one way if you have, sort of point-to-point connections of components, especially if they're immediately adjacent to each other or nearby each other, or if you're doing this on perf board, you can put them next to each other. Folding the leads together and soldering, perfectly valid. Another thing you might do is either use a bit of wire or use the cut-off leads of other components to make traces. So, thanks, Dad. Just put on your safety glasses. He's not wrong. He's not wrong. I'm very bad about it, but it's very good. So, one thing I might do is, let's say I had already used this lead. Let's say when I need to connect these 3 points of these resistors together, and this lead was no longer available to me. It had gone somewhere else, or I trimmed it off prematurely. Maybe it was soldered over here doing something else. It was already gone. One thing you can use is use this lead that I had cut off earlier. You can place it delicately. You can either do this from the front or the back. I'll show you both methods. You can take that lead and place it so that it is touching both of those solder joints on the back of your perf board there, and then just solder that in place. It can be a little bit finicky to do the first one, of course, because it's freewheeling. A little tape might help us out here, but I think we'll be okay. Here we go. Solder one there. Solder one there. And now I've soldered both sides of that wire, and now again I have electrical connection between both of those points. Now obviously this wire is touching some of the other metal pads here, and it's worth being aware of, especially if you have the kind of perf board that has through holes, has holes plated on both sides, because this wire is now conducting between not just those 2 points, but these 4 holes in the center. And if there was metal on this side, the same 4 holes on this side. And if you had a metal component touching them, you might be shorting something you didn't mean to. So just be careful when you're using this method that you're only connecting the things that you mean to and not shorting to anything you don't. You can do a similar thing either. I think I'm going to use a bit of wire because I think I've thrown away all my cut leads. You can do with a bit of wire to bridge 2 points. So cut off a bit of this solid core wire here. I should say, because I don't think I've said on these Sunday nights before, 20 gauge bell wire is a really great wire to have around for proto board. It fits really nice into these 0.1 inch holes that we typically use. It's pretty cheap. You get like a 50-foot spool for like $7 at Home Depot. It comes in typically a pair, red and white, which is really nice. You have maybe a power and a ground or 2 signals. Super cheap. And solid core wire for proto board. Stranded wire on proto board is a nightmare. If you have to do like a whip to like connect to something else, sure. But whenever possible, use solid core. So Chris, to go back to your question, another way you could create traces on this proto board would be to make yourself a little wire jumper with little stripped off bits at both ends. You can then solder that in place just like you would a component. So what haven't we soldered together yet? Let's say I have to connect these resistors together because this is the strangest circuit in the world. I could press that wire through those 2 holes in the top there, come down to my underside, and then just like before, I can use that bit of wire or the leads of the components or both. And I'll use the leads typically because they're a little bit thinner than the wire and just easier to bend. Bend those over so that everything's touching, and then solder them in place as before. So get the junction hot. I'll apply a little bit of solder. That soldered in place, that soldered in place. As it cools, I can come in with my flush cutters, snip, snip, and now I have a junction between those as well. If you're going to do that method, I recommend soldering not only the lead to the wire, but also the wire to the pad on the board. And if you're just doing a big flop of solder on there, you can see everything is soldered together. If you just solder the leads and don't solder the wire to the board, you can get a situation where like the components flop around a little bit, just jatter around in their holes. So even if they're electrically connected, the components are still wiggly wobbly. So that's typically not what we want. Yeah, so component leads folding over, snipped component leads as a bridge, or point-to-point wiring like this are sort of the 3 main methods of doing soldering like this. You can also, although I don't as much, but you can also just make little traces out of solder. So if you have your soldering wire here, and start getting that first pad hot, get the second pad hot, and just basically bridge multiple pads together with a bunch of solder. I don't find this super duper reliable, but I'm personally not typically building circuits on perf board that need this kind of like long bus structure. So you see how those pads sort of ended up bridged there. It's kind of a finicky way of doing it, and if you're going to need like a long bus, say for a bunch of power or a bunch of ground, you're better off doing it with, say, a piece of copper wire in the middle of it that really makes things conductive. Like you'd be better off soldering this copper wire in place and then covering that in solder, but that is an option I have seen sometimes. If you're doing multiple connections to a single point, you can obviously twist multiple legs of components together. Like let's say I've got this wire and this resistor bonded here. I could bend the leg of this resistor over now, and make all 3 of those connect at the same point. And you can, if you have 5 or 6 or 7 components connected in the same place, you're just bending a bunch of leads together and then soldering them. Typically one at a time is easiest. Oh yeah, Ken says you can put a little tiny piece of wire down in a bus and then solder along that to help them stick. That's a great idea. I've also done just like a long piece, just bell wire, because I use bell wire for everything. Just like shove that down a bunch of holes and then solder that in place. Yeah, that's the gist of making circuits with proto board. You can sort of see this is the one I had up at the very beginning of the night. Kind of has a variety of those techniques. So I have my zero insertion for a socket that we saw last week, and my ICSP headers that we were using to program little microcontrollers. You can see I have some wires that are bodged around to the back here to connect to specific places. I have bits of cut off wire that are bridging between points on the socket, and then I have some component leads that I just bent over and soldered in place there in various places. So it's totally fair game to make use of all of those as well. And if you get complicated enough, or once you've prototyped something, I encourage you to think about making a PCB, making a printed circuit board for your circuits, because that is a really simple way to make a repeatable design if you're going to be building many of them, or if it's a design that's complicated enough that wiring it by hand is going to be a major pain in the batukas. That is a thing you can certainly do. So question before we wrap up, because I see we're coming up right on a let's be fair, a Jeff Glass 90 minutes. Let me ask you which of these 2 topics are you more interested in next week? I may also not decide tonight, and I expect we're gonna not get consensus, so it might be a matter of figuring out which one I can more plausibly get prepared for next week. Those topics being circuit boards. We could do, since we touched on them a lot tonight, like the basic design and getting manufactured of your own circuit board. Or we can talk about basic wireless control triggers. So this would not be like Wi-Fi, but how to like send a bit of some data or some communication or some trigger between, say, one Arduino and another. Are sort of the 2 things that I think are on the radar. Or if you have another better idea, as always, I'm all ears. Wow, I can't tell you how satisfactory. It's great, like, just take my glasses off and be like, you kids out there, what do you think we should do now? Back in my day, it's very exciting. I might keep wearing these safety goggles sometimes just for the sake of being able to, like. So the thing is, that's very fun. When I was, we'll tell stories some other time when we're not 2 hours and 43 minutes into the thing. Ken says get the PCBs ordered because lead time. Yeah, we could certainly do that. Yeah, I see. We could like design a circuit board and then have it in hand while we're designing it the second time. That might be kind of an interesting thing. Travis says wireless. Yeah, because there's a couple of modules that sort of make it easy to like trigger things back and forth. We should talk about Wi-Fi too. I'm just not ready yet. Like I think Kenneth mentioned the other week the ESP32, which is like a Wi-Fi enabled Arduino-ish a Wi-Fi enabled microcontroller. Super cool. I'm not super experienced. I need a few weeks to like get up to speed on it, because then we should totally talk about it, because they're awesome. Or Kenneth can co-host. That would be kind of fun. Kenneth? No pressure, of course, as always. Yeah, well, neat. Well, thanks for chiming in, y'all. I'll make a call. And honestly, like a lot of the things, like what do I have on hand? What do I have here that like I can get within a week to do the next thing on? Oh yeah, I am learning so much by teaching you all. And this is a good point to start winding things down for the evening, which is that I really do love being here with y'all on a Sunday night. I love sharing things. I love learning things from y'all. I learn some stuff every week, and it's cool to like learn what people's like skills are and preferences are and backgrounds are, because I only have my one little way of doing things, and it's really useful to like hear what other people are doing out there. And I'm learning a ton by doing this, and that is really cool. I'm learning. About the physics of eutectic solders was something I didn't really understand until I did some research for this week. Or different species of fluxes, like what is RA versus RMA, was like super cool. So yeah, so it's been great. It's really fun to be here. I hope this is a place of it gives you strength to carry on the good work that I know you are all doing in the world, in whatever way that is, and even if that is keeping yourselves sane and healthy and safe, that is important to me right now. If those of you who are you know, out rocking gangbusters every day. I'm super proud of you too. Those of you who are using this time as to build the strength back up to make sure that you are okay, because that's what you need. I am super proud of you too. That's all right. That's as mushy as we'll get for the night. I still have half a beer. I'll go get mushy with my wife. That's our thing. We don't have to do that here. But anyway, I just think you're all great. Thank you so much for those who. I'll say all the business at the end here. You can find all the information about all these streams at the website, jeff.glass/electronicsbash. You can find me on Twitter at jeffersglass, where I tweet about nerdy things and sometimes social justice these days, but that's important too. If you have questions, comments, issues, concerns, please feel free to put them in the comments of this video, or if they're more time sensitive, reach out to me on Twitter. I'm often on Twitter these days. It's just interesting to hear what people are thinking, or leave a comment through the website. Ring that bell, like and subscribe. You don't have to. I really, it's weird, right? I really don't care about the numbers, but it's fun to know that you're reaching people. Hi! Oh my gosh! Stage managers! Hi, stage managers! Oh my gosh! Laura Glenn, hi! Oh my gosh! Vagabondophilia. I don't know who that is, but hi! Kenneth says smash the subscribe button and the patriarchy. Oh, Kenneth, that's so good. I'm stealing that. Yeah, really, really thank you all for spending these Sunday nights with us. I really do hope it is a place of strength. It can sometimes be weird to feel like, oh, it's an escape. It's not the time for us to be escaping, but I hope it is a place of building strength and confidence and learning and trying new things. Because it's fun to learn and try new things with y'all. I think it's been a really great time. Yeah, stay safe out there. Keep washing your hands. Keep eating your salads. Again, do as I say, not as I do. And I will see you at the next Sunday night here on YouTube at 7 p.m. Central. The decision about what next week's theme will be will be posted on jeff.glass/electronicsbash sometime in the middle of this week, whenever I can get around to it. Hopefully by Wednesday. That's been going pretty well. We're at 90 minutes for sure. Have a wonderful week, y'all. Goodbye.